Yes, sir. It's very
Yeah.
easy.
Okay, so last time we had ended up with something, some fundamentals related to machine learning and AI and some hardware we are going to discuss today. So what is planned for today? Let me tell you. I will cover some of the slides which were remaining. I'm not going to cover all the slides, but most of the slides are related to hands-on exercise. So that will be covered during the session. I have planned that I'm going to discuss two different platforms and technologies for implementing machine learning to the embedded systems, that is edge computing basically, or we call it as a physical computing also. So that is what is planned for today, and I will demonstrate you a complete example of sensor data analytics in terms of recording the sensor data from an hardware, and later on we will use that for training the model, and we will prepare the model and we'll deploy the model on the hardware, and even we will check whether it is working or not with real-time data. So this is related to something like gesture recognition based on machine learning. Usually there are lots of different ways of out gestures, like using computer vision you can find out pose and gesture and everything. But today what I planned is that I'm going to show you one hardware. If you can see that, so this is Arduino Nano, a very small but it's very powerful in terms of implementing the tiny machine learning model. So I will use this hardware today, and which I already connected with my computer, and we will see when it comes. So these are some of the use cases I will start with for the machine learning. Usually we have seen that like we do object recognition, object detection, speech and sound detection, natural language processing, prediction and translation. Number of applications are available in market for mobile applications, for desktop PC application, as well as hardware also. But we want to see that how these all applications are actually prepared and created. So many a times we might have observed that people talk about model, and sometimes we use some sort of inference also. So we are going to see that like how inference and a model is like differentiated. So first of all, what is a model in case of machine learning? A machine learning model can be mathematical representation of a real world process. So I mean to say, in a very simple layman's term, this is all about some sort of calculations or the answers for number of datas or number of features we have provided. Based on the algorithm or the network architecture, we have created that complete answer or maybe a bunch of answers into a file. That is nothing but a AI model. To generate a machine learning model, you will need to provide training data to a machine learning algorithm to learn from. So there are different ways. Based on we get different outputs because we provide number of features to the mathematical model to create, and finally we get the outcome as a model. So a functional representation, what we have seen in case of machine learning, how it differentiated from the computer programming languages is that we provide data and output and we get the program or maybe a kind of a model what we have seen so far. So this is a basic difference between training and inference. Many of you might have observed that like recently Jetson Nano is a very popular device. Google Coral Board is also a very popular device in terms of edge computing. So these devices are not capable in terms of running a training of say 1 TB of data or maybe hundreds of GB of data. It can do that, but it will take much time. So many a times it is required that not it is not possible every time to create a model. It is better that once somebody has already created a model, we can definitely use that model for our own purpose. So this particular slide talks about the difference between training and inference. Training is basically the process of machine learning algorithm builds a model of the system based on the data we provide. So in today's example, what we are going to discuss that we will provide a sensor data. Sensor is nothing but an accelerometer. So all these different acceleration in X, Y, and Z direction, and the combination of all these data will be used for training purpose. Once we get that, we get a model. So what is exactly inference is all about, that the process of running data through the model to make the prediction. So whenever we will use that model, then there is no need of training data or recording the data from the sensor, but the real-time sensor data will be fed into the model, and finally that is known as basically the inference concept. So here you can see that training versus inference. In case of training, we provide large number of data, like in case of images, what we have seen, what we are able to see in the image. that passes through the training algorithm, and finally we get some sort of prediction based on the model. When we have an inference, we simply provide some sort of input and we finally get the output. So that's a ready-made kind of a guide for getting the output. You will also come to know about different terminologies when we are into machine learning, and that is mainly from the Google. So that is known as a TensorFlow technology. Tensor is a word that has come from the physical quantities, like in case of deep learning model that accepts input and generate output in the form of a tensor. So scalar, vector, and finally we have a tensor. So tensor is a very huge multi-dimensional quantity by which we have lots of features. So main concept of developing the TensorFlow technology by Google was that, like, there were limitations when we use physical quantities like scalar, vector, or maybe matrices, and finally even the matrices were also multi-dimensional. And at that time, it was very difficult to do calculations based on that, and that is why the TensorFlow technology has arrived. So tensor is essentially a list that can contain either numbers or other tensors, and you can think of it as similar to an array. It's a multi-dimensional array, or maybe you can say you can scale up like anything. As much as number of features or the data you have, you can use TensorFlow technology for that. So scalar, vector, and finally we have a tensor. So just to understand in a different way, scalar is something like one physical quantity, vector, and matrix, and finally tensor. So tensor is a huge feature embodiment by which we are able to process the data. So it's a single number, a list of number, two-dimensional array matrix, or maybe three-dimensional array. But like when we talk about tensors, they are higher dimensional matrix and any shape with more than 2 dimensions. So if you want to know more about that, there is a very good link which I have provided. I will definitely share this slide with all of you, so you can refer the links which has been kept from the source from where I have taken this data. Another difference is what are CPU, GPU, and TPU? Usually, we know that like CPU and GPU are very popular terms. In our laptops, if we buy today any latest laptop, we get CPU plus some sort of NVIDIA's GPU capability. So that is graphics processing unit. It provides an enhanced memory mechanism by which we are able to process the information or the data very quickly and faster. CPU is normally Intel's processor or maybe AMD or any other processor which we use. But when we are dealing with machine learning, when we are dealing with artificial intelligence, when we are dealing with image or a audio or a video or maybe any number of huge amount of data, and as we have seen that when we are having multi-dimensional metrics, we want to go for the tensor processing unit, and that is what is done by GPU and TPU. So the main difference between this is that, like, performance, CPU can handle tens of operations per cycle, while GPU, this is about the CPU only. So the usage is CPU is generally for general purpose programming problem we use normally in day-to-day life computing facility. GPU can handle tens of thousands of operations per cycle. So you can see that the capability and powerfulness of GPU as compared to CPU, while TPU can handle up to 1,28,000 operations per cycle. So now you can understand that when you have a TPU in your machine or maybe TPU on a development board, at that time it is considered to be the fastest one. And usage, like in case of graphics rendering machine or maybe 3D Studio Max or maybe modeling or AR, VR, we usually go for GPU, or for video editing, etc. We go for GPU. Even for AI and ML, we have GPU cards by NVIDIA, which we use for training purpose. So it is efficient for programming problem with parallelization scope. So when n number of activities are to be happening concurrently, then at that time GPU is one of the best solution. Well, TPU is meant for machine learning model only in TensorFlow model training and inference. So TPU is basically a kind of a proprietary technology by Google, and that is why only the boards which are supported by Google are having TPU capabilities on that. These are some of the images from Google's Coral board when we use that. It is not much important right now, but we need to look at the challenges for ML also whenever we are designing or whenever we are working on some ML problem, or maybe we are guiding a student for a dissertation or a PhD work. At that time, we need to keep in mind that the first thing is that overbearing prerequisite system knowledge for setting up the environment. We need to know very well what are the prerequisites, what are the things we need. Most of the time, it happens that a student comes with a very good problem statement, but because of we do not have enough infrastructure facility in terms of computing facility, I mean to say, for machine learning problems. At that time, we need to see that what are the prerequisites we have, what are the facilities we have. I will suggest all the faculties that like NVIDIA is having a very good university program. You can simply propose a research proposal on their website. There is a program called NVIDIA University Ambassador Program for Jetson Nano. And if they like your proposal, they definitely will give you some sort of kits or maybe GPU card costing 1,50,000, 2 lakh rupees. You need to set it up into your desktop machine, and you can use that machine for machine learning projects or maybe research work. If you want to go for embedded system, then definitely NVIDIA will help you with the Jetson Nano kits. I would like to show some of the kits which I have recently received by NVIDIA. This is the box which I have like maybe 1 month ago I received. There are lots of such kits available. So this is one of the NVIDIA Jetson Nano kit. I've received 20 kits from Jetson Nano, NVIDIA. So I give it to my students, those who want to work on machine learning problems related to electronics and communication, or maybe they have some project work, they can definitely use it for that. So you need to see that the challenges of machine learning should not be a problem for your research work. Second thing is it is difficult to know exactly how much data is required to train an effective model. That is very important thing. We had also discussed in the first lecture that we cannot collect the data of from the world. I mean to say, we may have some sort of bias, specifically geographical bias, and that is why we need to see that how much data is required on which particular location or geographic area or maybe particular application or case study we are targeting, and based on that we need to collect the data. There is no guarantee that you will be able to achieve good enough accuracy for the problem you are trying to solve. It depends all on your model architecture, the technologies which you have used. And it is obvious that like as a faculty, we use this sort of development boards. We use our normal day-to-day machines or maybe at least some GPU enabled desktop machines, but we cannot have the computing facility like supercomputers or maybe GPU arrays or GPU server farms like Google or Amazon. So definitely research is going to be affected based on the quality of the infrastructure we have, the scalability of the infrastructure we have, and that is why we cannot be that much sure that what we are going to get would be exactly the final version of the research. So we should understand, and obviously we need to accept this situation. Now this is a very interesting part that we need to understand what is exactly the workflow for any of the machine learning projects. First of all, we need to decide the goal on which particular broader area or to some specific area we want to target for making a machine learning project. We need to collect the data set. Usually in step number 2, we go for available data sets on the internet. Kaggle is the best example of the website where you will be able to find huge amount of data sets for learning purpose. Even they have different challenges coming up every week or month, by which people across the world actually try to compete and find out different accuracies and different versions and variants of the software codes, and they contribute it to the Kaggle. So Kaggle would be a best example to kickstart or any of the data set you want to download. Whatever data set is in your mind or whatever area which is in your mind, you can definitely search those related data sets on the kaggle.com site. I hope all of you will be aware of the kaggle.com site, and it is very interesting and one of the most important and very popular website for machine learning projects. Then design a model architecture. You need to be very much clear that which sort of architecture do you need, and it all depends on the data, the size of the data, the variety of the data, the outcome, the accuracy in which you are targeting. All these parameters will affect designing a model architecture. Then we can use our normal desktop machines and the programming languages which we use for training the model. Finally, we will convert the model for the targeted device, because whenever we are targeting the specific technology, say for example it is desktop computer, then definitely a normal created model will work because we have a setup environment in the desktop machine. But when we are targeting different hardware platforms, if it is NVIDIA Jetson Nano, if it is Raspberry Pi, if it is Arduino Nano, if it is Sony S Presence, if it is ARM Cortex board by Texas Instrument, if it is another which is variants of all these mini computers, then definitely all the libraries which we are converted into the binaries are basically a kind of a conversion of the model from one file to another file, and that is what is very much important. And then finally, after loading that, you need to write a program to run the inference and finally evaluate and troubleshoot the model whether it is working perfectly or not. There are some examples I would like to show as an image which I have collected from the internet. These are some creative and innovative example of machine learning physical computing using microcontrollers. So the first is very interesting one, like it's a objectifier special programming. So whenever you click on a switch, which is an Android application, the light which is connected with the Raspberry Pi or maybe Arduino Nano will get switched on and off. But that is basically because of the machine learning model which has been running inside the Android application. And this is again an experiment of the Google. So you can refer this link experiments.withgoogle.com AI. You will find all these examples over there. This is another interesting machine learning project, which was also available for the Arduino 101 platform. It's Intel Curie pattern matching dress, means whatever is the space and astronomy condition, that sort of images will be generated on your clothes. So it's all about like transferring those images based on the astronomic condition into your clothes. This is also available on the internet. This is something like playing a kind of a gesture recognition media player. Whenever you shake your mobile phone or maybe you move your mobile phone or maybe a hardware which you have used, it will change the song, it will increase the volume, etc. So that is one of the, I already provided all the links in the slide. So whenever you will click on that, you will be able to directly jump to that project. This is again a very interesting rock, paper, scissors machine learning program and hardware setup by which whatever gesture you will do, like if you do rock and paper and scissors, something like that, the arrow will move towards those signs and finally you can play that game. And something about ML embedded systems, what are the different hardware available in the world today? So the very much popular is the NVIDIA's Jetson Nano boards. This was an older model, but nowadays we have a different sort of smaller kits available, which I recently show you from the box. It's cost something around 7 to 9,000, available everywhere on the most of the online platforms in India. You can buy that and start working on that. They have a complete guide and a dedicated blog on the website, which you can refer for kickstarting some of the projects. This is a very interesting one, SparkFun JetBot AI Kit. So those faculty members who are interested in working on an autonomous vehicle, say for example, you want to make an autonomous car, a driverless car kind of a concept. So we cannot have a complete physical car what we use in our day-to-day life, but we can definitely create a jetbot kind of a condition on a hardware, and you can train this hardware in your room or maybe on the roads. It will capture all the video images, it will convert into the frames, and finally whenever you leave it on the road, it will take number of decisions like an autonomous vehicle. It will be based on how you have trained it. So say for example, I have my table, and if I run that car on my table, and whenever it reaches to the boundary, I will stop that car, I will take a turn of that car, and finally it will learn that I need not have to go to the borders of this table, and I need to take back the turn, or maybe I need to take a U-turn from that. So after that, once the training is complete, if you load that model onto the JetBot, definitely it will work like without any controls. It will never fall down from the table, and it will work perfectly. Having almost more than 90% of the accuracy, it will work fine. So this is also a ready-made kit which is available, but you need to buy this, and Jetson Nano is to be installed on the car's assembly, and it works fine. It is available on the Seed Studio website also. You can buy that. It is known as a JetBot Seed Studio kit, which comes without all and also with the NVIDIA setup. So both the options are available. This is our very popular platform. Everybody is familiar with this Raspberry Pi. So I will not discuss about that. In Raspberry Pi also you can run machine learning models and algorithms, and you can create lots of computer vision based application, or maybe if you connect a USB microphone with this Raspberry Pi, you can create a speech recognition related application also. Even you can completely port the Google Assistant or Amazon Alexa, changing the hot words of this particular device. You can create Amazon Echo Dot kind of a machine using the Raspberry Pi. So there is a dedicated blog available on the GitHub by which you can transfer those files for Amazon Alexa. And usually when we call Amazon Echo Dot, like, hey Amazon, sorry, hey Alexa kind of a thing, or a hot hot word or a keyword or a buzzword we call it. You can change those words also. There are different methodologies available by which you can change. So 2 3 years back, I had developed assistant called Vidur. Vidur was one of the intelligent minister of our history, and he used to give all the answers very well. So I created a Vidur assistant, and I had given number of questions and answer to them, and it was based on the Raspberry Pi only. I have a YouTube video also. If you want to see that, I will share later on. So that Vidur works fine because I had actually ported the Google Assistant completely on the Raspberry Pi, and based on that, it was able to answer well. And you can even make some other applications based on the TensorFlow Lite technology. TensorFlow Lite is again a machine learning library from the Google based on Python, which you can use for any of the applications. These are some of the Arduino boards, like Arduino 101 is also supporting the machine learning, but it is not widely used in India. We use normally Uno and Nano and other latest Arduino platforms. This is one of the interesting kit if you want to do a quick start. It is available on Amazon, even on Amazon India website also. The first kit is known as Vision Kit and second known as a Voice Kit. So Voice Kit is similar to what I was discussing about like Amazon Alexa making a kind of a similar device using Vision Kit. So Vision Kit also comes with a Raspberry Pi and some preloaded memory card of this Google Assistant port on the memory card directly. You can use as per your requirement. This Vision Kit can be used for object detection, image classification, etc. And it has lots of other libraries available in built Vision Kit. So for those who are high school students or maybe the college first year students, if they want to have a quick start on machine learning on embedded systems, these are some of the best kits on the internet which is available right now. They are known as Google AIY kit. This is one of the little bit advanced board by Google. It is known as a Google Coral board, and there is an accelerator which is also available, which is in on the right side of the image, which is a white color USB stick kind of a thing, which you can insert with a Raspberry Pi. Because Raspberry Pi cannot handle training because it has only 1 GB of memory. It does not have any higher CPU power or no GPU facilities available on the on the Raspberry Pi. So once I had tried to train a model on Raspberry Pi having some 200 images of those gender detection problem which we discussed last time. So what happened within 30 seconds or 1 minute, because of lots of computings were happening on the Raspberry Pi, the temperature of Raspberry Pi was increased to 98 degree, and almost it was like heated up and all the performance were down because Raspberry Pi is not a device to have a training on that. It can run the inference definitely, but it is not a device by which on which you can train the data. So when you want to provide a GPU capability to the Raspberry Pi, it is very much important that you provide a accelerator kind of a thing. So there are two types of USB sticks available in market right now. One is by Google Coral. So you need to simply insert that white color USB stick to the Raspberry Pi. So now your Raspberry Pi will be having a GPU capability, or I mean to say TPU capability also. And another one is by Intel, that is known as the Intel Mobius stick. That is also costing around 9,000 rupees, and this Coral stick is also around 7 to 9,000 rupees. So to make our Raspberry Pi a powerful machine learning platform, these are some of the external USB sticks that provides a GPU and TPU capabilities to the embedded system of our normal day-to-day life. But when you go for this sort of Google Coral board, it has already inbuilt TPU on that, and that is very faster in terms of running a model, training a model, and like running an inference also. Okay, so these are some of the examples which are available on the Google Coral's website, like image classification and object detection, how it is done. All the examples are available. This is for image recognition with the camera. If you connect a camera with the Google Coral board, any normal USB camera will also work with this. So you can connect those cameras, and finally you can do image recognition with a camera with some sort of accuracy based on the model which you have deployed. There are lots of ready-made model and algorithms and network architectures available which you can use, like MXNet and VGG16 and MobileNet and Inception and all these models which you can directly run as an inference. Pose estimation is also an example which is available on the Google Coral website, which you can use for the pose estimation. Yesterday we had seen, a day before we had seen the Google Teachable machine. So that Google Teachable Machine pose estimation network was using the same model which we are able to see right now on the example section of the Google Coral board. These are some of the Google Coral projects like embedded teachable machine and smart bird feeder. So what was the scenario is that in the second example of the chessboard, a person is showing some sort of elements of the chess to the camera. You can see that there is a camera. So whenever it identifies a particular horse or any elephant or something like that, it will be able to switch on the lights. So it has already been trained with Google Teachable Machine, and that has been deployed. The model has been deployed on the Raspberry Pi, and the Raspberry Pi is connected with a camera. Okay, now coming to the main part of like what are the things we need to keep in mind, because when we are making a project, it must be a research project, and that is why we need to look into number of factors into the account. First is the functionality, like wanting a smart device to act quickly and locally. That is what the first important aspects, that we want to make a device smarter and smarter. Cost is also very much important. We cannot buy a 2 lakhs of computer having a GPU capability and we are running a very small project on that. So based on the requirement, we need to see the cost also. Privacy, like not wanting to share all sensor data externally. Why we want to go for the edge computing device is only and only because of the privacy concern. We do not want that everybody's data should be uploaded to the cloud, and that is what the main concern is all about, that every processing, every uh, machine learning model should run locally without the cloud support, and it should identify what exactly the prediction is all about. Efficiency is like smaller device form factor, energy harvesting, or a longer battery life. Efficiency is also very much important, that it should run on a battery, and the battery should also last very long. This is another one by SparkFun. SparkFun has also provided some edge computing boards having a camera from Himax. Himax is having a very good sensors for the camera. If you want to buy these boards, they are available on the sparkfun.com website, by which you will be able to run TensorFlow model. And SparkFun has dedicatedly made this board for TensorFlow support only. So all the TensorFlow examples which you will deploy on this device will run very well. Person detection and magic wand and other examples for speech related to, like say word detection, keyword detection, etc. This one is by ST Microelectronics. It's known as an STM32F7446G discovery kit that comes with a display. So many a times it is important that we want to display some results. We want to use some output and we want to display that output. So at that time, if a board comes with a display, like previous all the boards what we have seen so far doesn't come with a display, and that is why we need to use any LCD screen, or maybe we need to connect to the HDMI cable to the computer's display, something like that. But this comes with a display, so that is the only difference. Another very interesting board, very smaller one, very low cost, runs on a very smaller battery of lithium ion 3.7 volt. It is from the Adafruit Edge Beige kind of a board. It is basically only for TensorFlow Lite for microcontrollers. Because whenever you will visit the TensorFlow website, you will come to know that TensorFlow has various variants of these TensorFlow libraries. One is for normal desktop computers, and second one is for mobile phones, like specifically for Android phones. Third one is for microcontrollers. So they call it as a TensorFlow Lite technology, because normal TensorFlow is for computers, but whenever you read the word called TensorFlow Lite means the model size would be very small. It can run on an Android application, inside the Android application, or maybe you can deploy it on a smaller hardware like Arduino or any of the boards which we are able to see right now. And even the beauty of this board is that it comes with a display, and there are lots of controls are also provided, like there are 4 switches and some sensors and some start switch on and off button, and number of data pins available on the board. So it also comes with a microphone. So you can see in the another image there is a microphone connect. So you can do speech processing related application, and the example which is available in the photograph, which shows that say yes or no and see if the machine learned or not. So you can train by speaking the words, and you can start with some sort of basic projects on that. This is yet to uh, be launched, but I think now it is launched. The slides I made few months ago. So machine learning braincraft head for Raspberry Pi. you are already having a Raspberry Pi and you want to run a machine learning model or an inference on the Raspberry Pi and want a display, you can definitely run that thing on the Raspberry Pi, but it will not be able to help you to train the model. You need a already trained model. You need to simply run the inference on the Raspberry Pi and that will work. And this is one of the main player of today's session, what I'm going to use this, because I love this board. And why I like this board is that there is no need to connect all the sensors externally, because it has everything on board, and the cost of the board is also not much. I mean to say nearly about 3,000 rupees, because when I purchased this board, I purchased 1 year ago, and I actually imported from the US at that time because it was not available in India. And at that time, the cost of buying from the Amazon.com website in US dollar was something around 6,000 rupees. I also need to pay some 2,000 of custom duty. So for me, it was very costly, but nowadays it is available on all the online platforms, nearly about 3,000 rupees. So the first difference as compared to all the other older Arduino boards is that like it is having an ARM Cortex microcontroller running at 64 megahertz with 1 MB of flash memory. So the flash memory is also very big, and 256 KB of RAM. So most of the calculations which will happen on the machine learning, because of machine learning, will be a little bit quicker as compared to normal Arduino platforms. Another thing is the main part why it is so much popular is that it has onboard sensors. 9-axis inertial sensor, what makes this board ideal for wearable devices. Whatever wearable devices you want to make using this Arduino Nano will be a perfect choice to use this, because if you want to make a wristwatch having a to measure the or to monitor the physical activity, whether your sleep pattern was excellent one or not, it is all measured because of the accelerometer. You might have observed that in case of Apple Watch, which is a smart watch, as well as the Samsung Gear Watch, both of these watches provide you lots of physical activity options of running, cycling, swimming, walking, etc. It immediately identifies, even though you do not go to that mode and select that mode of physical activity, by just finding out or getting the information from your gesture or the body movement, it will identify that you are walking, you are cycling, etc. Another important aspects in the watch which I have observed is that it also measures the ECG or the heart rate. Many of the watches are also able to measure the SpO2 level as well as the blood pressure. But what I found interesting is that one of the Samsung watch which I was having was able to measure the stress level. So stress level is again a very important aspect, that like how a smaller wristwatch can identify the stress level of a person. So when I digged all the details of these papers, I found that the stress is basically measured on the RR interval. RR interval is nothing but a kind of a ECG. Whenever we take a cardiogram of a person, and during that cardiogram, whenever you look at carefully, all the ECG patterns, a single unit of the ECG pattern are having a PQRS pattern that everybody knows well. So the P, Q, and R. R is one of the little bit higher spike in the waveform. And whenever you get another cycle of that ECG or the heartbeat, you get another PQRS. So measure the distance between these two R intervals. Means the first R of the PQRS first waveform and the second R of the second waveform. So the distance between these two R is basically responsible to tell you that whether you are stressful or not. So that was a very interesting paper, and based on that, lots of calculations or the data which they have fed to the machine learning algorithm for training the watch based on the RR interval ratio. And again, like normally what we consider that if the RR interval is accurate, means like if I take my ECG and I measure all the RR interval or the distance between two R spikes in my PQRS waveform, if I find that these are all equal, then it is good, but it is reverse. If all the RR intervals are equal, it means that you are stressful. There should be a variation in all the R's for the RR interval, I mean to say. So this watch actually measures the PQRS and finds the RR interval, and based on that, it gives you a 0 to 100 kind of a meter, and it shows you that okay, you are 64% stressful right now. It depends when the data was taken. It depends on which condition you are. It depends on lots of conditions and activities. But if you measure it for period of 24 hours or maybe for few hours, at that time you will come to know that whether you are stressful or not. So these are all useful for wearable devices. What I mean to say is that using Arduino Nano 33 BLE Sense can be a very good choice for making wearable devices. We might have seen there are lots of Atal FDPs were also going on based on IoT and wearable devices. But this is one of the most popular, which everybody talks about for making a wearable IoT applications or wearable machine learning applications. It also gives you humidity and temperature, so you'll be able to measure the temperature very accurately. It is not like a normal LM35 kind of a terminal or sensor on that. To get highly accurate measurement of the environmental conditions. Barometric sensors gives you lots of information about weather condition or can be used in the weather stations also. Microphone is again a very high sensitive microphone, supports the complete frequency band of audio frequency, and it is so sensitive that whatever data comes in, it will be able to capture those and take the action as per your application which is running inside the Arduino Nano. Gesture, proximity, lights, color, and light intensity sensor estimate the room's luminosity, but also whether someone is moving close to the board. That can also be identified. In our normal mobile phones, there is a proximity sensor close to the front camera. So whenever we take the phone close to the ears, the proximity sensor identifies the proximity of the human ear and it immediately switch off the display. And that is why, or it disables basically the touch capability of the LCD screen. And that is why this can be used for that sort of application. If somebody is moving close to the board, you can identify that using the proximity sensor. Looking at some sort of memory aspects of the board is that flash memory, as I told you, 256 KB, sorry, 1 MB of flash memory and 256 KB of the RAM. Atmega 328 chip was found on this board, but nowadays we have an NRF 284 chip found on the Arduino BLE 33 Sense. BLE stands for Bluetooth Low Energy Radio, which is capable of connecting to the number of devices altogether. Now, if you want to connect a camera with this board, there are lots of options available by which you can connect. So Arduino Mini 2 megapixel plus camera, which is a very best example for connecting with this board. And if you want to start with that, like who started all these tiny machine learning development, is one of the workshop you can refer on the GitHub by Sandeep and Don, and another was by Prete Warden of Google. So all these three are the pioneers in developing tiny machine learning applications, and they have given very good example, which I have created as a link in this slide. Person detection with TensorFlow Lite, Magic Wand with TensorFlow Lite, micro speech with TensorFlow Lite. All these are available on these links on the GitHub. Okay, now we want to start with some fundamentals that we want to see that how we are going to run this model and how we are going to capture this data and everything. So this is one of the photograph of a run application which is running. If you say yes, the LED will be green. If you say no, the LED will be red. But it is not simply by getting the microphone details or maybe a kind of a speech to text conversion. It is based on the machine learning model for speech which is running inside the board, and it identifies the keyword what you are speaking all about. Google has a very good trained model for almost all the speech keywords which you can use directly or maybe use inference of that, and you can use that. This is one of the example by TensorFlow Lite, which you can use for any of the mobile application to make. So this mobile application will help you to identify all the objects which are available in the models which are available on the site of tensorflow.org Lite models. So these are all Lite models, means there are two types of versions of the model. If you want to make a desktop PC application, then you can go for the bigger models. But when it comes to light memory size or low weight, I mean to say lower memory size of the model, you should go for TensorFlow Lite models for image classification, object detection, or speech recognition. Machine learning microcontrollers, TensorFlow Lite is supported by all these variants of the different boards available in the market. The one which we have already seen, Nano 33, SparkFun Edge, ST Microelectronics, Adafruit Edge, Adafruit TensorFlow Lite microcontrollers, Adafruit Circuit Playground, Bluefruit, Expressis, means ESP32 I meant to say, and ESP32i, that is ESP32 Chem. So even though having a very smaller ESP32 module inbuilt with a camera inbuilt into that, you will be able to run a machine learning model into that also. That is one of the best example that if you don't want to connect an external camera with the Arduino Nano 33 BLE, you can definitely go for ESP32 camera. And these are some of the links, TensorFlow JS. Okay. Now the board, where the sensors are located on the board. Look at the orange square on the board. So this is the area where color, brightness, proximity, and gesture sensors are in terms of an surface mounted device, SMD components. Yellow is basically the motion, vibration, and orientation sensor. That is 9-axis inertial measurement unit. This green is basically the temperature, humidity, and pressure sensor. So related to weather conditions, you can get sensors over here. Blue is basically the microphone. And the bigger one is the ARM Cortex M4 microcontroller and BLE module in a one chip. Now, how you can get the embedded intelligence or maybe embedded artificial intelligence? Because of all this development in the machine learning as well as in the embedded system, the main feature of the board is, beside the impressive selection of sensors, is the possibility of running edge computing applications onto this board using tiny machine learning. You can create your machine learning model using TensorFlow Lite specifically, and upload them to your board using the Arduino IDE. Okay. Now, very important aspect, because once you buy the board, you will not be able to run directly because you need to do some setup, and that is also very important aspect. Those faculty members who have already worked with ESP32 on an Arduino IDE must be knowing that you need to do some sort of setups. It will not simply by that you connect it with the USB port and connect it with your computer, open the Arduino IDE and the board will appear as a list. It will not appear because you need to install lots of other support required libraries for Arduino IDE. So very basic thing you need to keep in mind for Arduino Nano specifically is that go to the Arduino IDE, go to the boards manager, and then finally write or search something like Nano 33 BLE. You will be able to get the library for Arduino Nano 33 BLE and click on install. And then you will be able to see that in the boards manager, you select the board and you will be able to find that Arduino Embed OS Nano boards. And under that, you will be able to get this board as a listed one. So this is the first step when you are starting your application development with Arduino Nano 33 BLE. If you don't install the libraries required for Embed OS Nano boards, it will not appear. You will not be able to connect your board. Physically, you will be able to connect the board, but it will not be listed and you will not be able to select that board for writing and loading the program. Second part, you must understand the sensors which are inside or the onboard to the BLE board. This one is the sensor for accelerometer, gyroscope, and magnetometer. So you need to know and understand the name of that sensor. That the IMU is basically LSM9DS1. The microphone is basically MP34DT05. All these details you can get from the datasheet of BLE33 Nano, but you need to install the required libraries into the Arduino IDE. Otherwise, you will not be able to use these sensors. As we know that whatever electronic components, sensors we want to use for our programming, we need those libraries because we need to use those functions. We need to record something, we need to measure the acceleration in the x direction, we need to find out the magnetic field in the north direction. There are a number of aspects we need to identify, and based on that, we have to install the required libraries. So I have written the library names also, like library Arduino LSM9DS1 is for accelerometer. This PDM library is for microphone. Similarly, we have gesture sensor called APD S9960. So the library for that is Arduino APD S9960. The barometric pressure sensor is LPS22HB. We need to install the library for that also for Arduino, that is known as Arduino LPS22HB. So whenever you go to the Arduino library manager, you can install all these libraries. So you need to keep the board ready, your IDE ready for all these activities or maybe the sensors which you are going to use for your program. Relative humidity, we have HTS221. For gesture sensing, we have a library called APDS9961. Okay. Now, from up to this slide, it was all about the boards. Now we have lots of options available that how we want to start. we have two options. Either we can go to the Arduino IDE first, or maybe there is another one is an online cloud platform called Age Impulse. This is one of the most popular platform today and even very easy to use. It allows you to even generate the code automatically. You need not have to write anything. Even it does not require that you have to create the model for different devices by writing a code. You need to simply select the board or the target board that I want to create the Arduino code for my Arduino Nano. I want to create the code for my Sony S Presence board or maybe for Raspberry Pi. Or even though you don't want to do anything and install or write the program for Arduino, you can create the complete firmware. So download that firmware and flash your Arduino with that firmware. So that will be a kind of an ASIC board. I mean to say application specific interface kind of a board that it does not require any writing of the programming or burning of the program. You change the bootloader, change the firmware using the bootloader, and the Arduino Nano will be running a machine learning application directly. So first I will start with the Age Impulse platform. It is very easy and even very easy to understand. Everybody will like this particular platform once I will show that. So the process of Age Impulse is that Age Impulse is basically a cloud-based machine learning platform which supports tiny machine learning or edge computing, and it supports variety of the boards. If you use Arduino Nano, it may not support Raspberry Pi to write a program, but Age Impulse will give you an option that, okay, you have created a very good machine learning project, but now you want to share it with some friends who are using Raspberry Pi, or maybe some friend is using Arduino Nano, or some friends are using Sony S Presence board. You can share the same project and they can target those devices and deploy as per their specification of the board. So this is the Age Impulse platform. Now what Age Impulse process is all about. I will share the Age Impulse website also first of all, and then I will show you. I need to go to the sharing option of this meeting. Yes, sharing. I hope it is visible to you. ageimpulse.com.
Yes, sir.
Yes, sir.
Okay. So you can go to ageimpulse.com, create an account, log into that. This would be the first screen that you want to create a new project. So right now I had created number of projects into this, but if it is available, it will show you the list which you have already created. But if it is not that, you can create a new project here. So first of all, I will create on new project. I need to give a name, something like UGC, HRDC, kind of a project I want to create. So the project is created now. Now what is the second option or the second step? It will give me options for data creation or data collection, or maybe if I already collected a data set, I can use the ready-made data set for my project. The project which we are right now going to do is a machine learning project for edge computing for any of the embedded system which are being supported by Edge Impulse Studio. Okay, now this is the first screen after creating or writing a new project name. It allows us to play with accelerometer data. It allows us to use data related to audio, images, and something else. If you don't have all these targets for your project, you can have some different data, like you have a CSV file of finance data, or maybe you have a data for some videos, etc. You can use any of the options. But let us start with some fundamental part of this. So let us take an accelerometer data example. So now it gives me two options, that what sort of source you are going to use for accelerometer data. Whether I'm going to use my mobile phone accelerometer to collect the data, or I am already having some hardware like Arduino Nano or OpenMV or ST or ETA Compute, HiMax, Scilab, or these are boards which are being supported right now by Age Impulse. So if I go for that, I need to connect your development board, or maybe read the tutorial for another one. So right now, say I'm not going to connect any of the board right now, but if I click on that, what happens? It will ask me to list out and select any one of this board, and there is a procedure for that, how you can connect the board with you with this platform. Because remember one thing, right now we are on a website, and when our board is connected with our desktop PC right now, say for example in my computer I have this Arduino Nano which is connected with my desktop machine via USB. Okay, how the data of this board can go to this website directly? I need to get a port access for this website called Edge Impulse, and that is why they have created a kind of a firmware that you need to install the Edge Impulse firmware on this Arduino first. So that will allow this Arduino to start sending data directly on the Edge Impulse platform. If it is not there, then don't worry. If you don't know that thing, I also prepared that PPT and all the steps have been listed, that what are the things you need to do to install that firmware Arduino and change the firmware of the Arduino, and finally you can upload this data. Right now, not going into all the complexity and detail, but just to understand the platform of Edge Impulse. Right now, this is the project which I have created, like Kiran, under the Kiran's folder, there is a project called UGC HRDC. So now it gives me an option that acquire data, because we want to say create a gesture based application. Maybe today like I'm going to demonstrate something like that. If I write 2, मैंने यहाँ पे हवा में मतलब एयर में ऐसा लिखा कि 2. If I write 3, if I write 4. So these are some gestures by which I'm writing some. Okay, whenever I am collecting the data, I need to do this sort of gestures 100, 200 times. If I want to record the data for 2, I will do something like this. So the accelerometer inside this board will collect number of data for this 2. And it will be a combination of AX, AY, AZ, AX, AY, AZ, AX, AY, AZ, and all the combination will be stored into some file. And whenever I prepare a model, and if I deploy it on the hardware, and if I write a new program, then whenever I will do something like this on my screen, it will print 2. If I write 3, it will print 3. So it will identify the gesture based on the training which I have provided to this board. So first step is that we need to acquire some data. Every machine learning project starts with the data. You can capture data from a development board or your phone, or import data you already collected. So we have three options. Either directly collect the data from the board. If you already prepared some CSV file, upload those files, or maybe you want to use your mobile phone, because mobile phone too have an accelerometer inside that, and you want to create some applications based on that. मान लो कि आपको like fall detection का बनवाना है application, or maybe you want to create an Android application for fall detection, that whenever some elderly people are carrying that phone और उसको कुछ मतलब they fall down, it will immediately call to some emergency number. So you want to identify those motion activities of accelerometer from the phone itself. Then you can collect the data from the phone also. Second portion is design and impulse. Design and impulse is nothing but like preparing the training algorithm, get your data trained, and finally prepare a model. And final step is that deploy your model onto the hardware, whether it is a mobile application in terms of Android, or maybe whether it is for Arduino Nano, whether it is for Raspberry Pi, whatever you want to do, you can do that. So the first part is that. Second is devices. आप जब devices में click करते हो on the right panel, on the left side panel, it will show you the devices which you are using right now, or maybe which is connected. I don't have connected any of the devices right now with the Edge Impulse platform. Definitely, physically my Arduino is connected, but I have not changed the firmware of my Arduino so that it will get the data to Edge Impulse platform directly. It takes some time to open. So, okay. So right now, no devices are connected yet. Second is data. The third one is data acquisition. It's taking time. Okay. So right now, it shows the data acquisition part in the Edge Impulse platform. Collected data, no data yet collected. And there is an option of upload existing data. So if I have already recorded the data, or if I already created the data in another platform, or maybe in another format, I did not have to connect any device, but I can directly upload the files over here. So now what I will do, I will show you a project in which there are some data. Right now I have created the UGC HRDC project, but no data are there. So what I will do is I will show you a project in which I have already uploaded some data. So it will not take much time and you will be able to understand it very easily. Okay, I will open. Okay. So in this, you will be able to see the difference. In the previous, it was an empty project, so nothing was available. Here, some devices are also connected, data collected for 11 minutes and 31 seconds. These are all sound data which I have uploaded. And if I go to the devices, it will also show me the devices which I have used to upload the data. So it shows me that I have used my phone to collect the accelerometer and microphone data to this. If I go to the data acquisition part, I don't know why it is opening. It takes too much time to open. Whether it's a very fast platform, but today it is taking some time to open. Okay. What I have done in this, you can see that I have uploaded some data and I have given some labels also. These are all, as I told you, related to the mosquitoes' wing beat sounds. This is for RB type of mosquito. This is for A. aegypti. If I click on any of this part, it shows me all the data which I have uploaded or collected related to A. aegypti kind of a mosquito. If I click on that, I will be able to see the waveform also for that, and I will also be able to check the sound. So you can listen the sound if it is audible to you. These are all mosquito wing bits. I hope it is audible to all
Not
of you.
not audible.
I need
Not
to.
audible, sir.
इसमें कोई ऐसा ऑप्शन है कि like to have my system sound, I need to do any changes into that. मतलब कोई ऐसा जैसे माइक्रोसॉफ्ट टीम में ऑप्शन है you want to use the system sound. Anyway, this is a mosquito wing bit sound. No matter if it is not audible to you. Okay, now once you upload all this data using this upload existing data button, it will actually classify, it will display all these, and it will classify in terms of the label, length, and time, and the name of the file, etc. And it will also show you that the total data is basically for 9 minutes. This is for 2 minutes, and this is for 3 minutes. So total 1 second of file length is available. Every file is of 1 second, and these are all completely uploaded data. It means that right now I have a supervised data, means I have already given some labels to those files and I have uploaded. When I have uploaded, there is an option to give everything. So let us look at this. When I click on upload the data, if I want to add data to this, it will ask me whether you want to give any new label, want to upload to an existing one, whether you want to automatically classify, automatically not classify, but automatically distribute the data for testing and training purpose. Everything will be asked. Why I'm showing this platform is that as a beginner, sometimes it takes too much time that how I should write the code, how I should prepare the data, how I should classify them, or maybe I need to create a model. But this is a kind of a user interface by which you are able to do that, and you will also be able to see the code. Then later you can change the code also. That is also possible. So this upload existing data gives you an option that automatically split between training and testing. So if you are uploading 100 of samples, it will split between 60% for training, 40% for testing, etc. If you want to exclusively upload the data for training, then select training here. You can give the label also, like if I want to give some another label, that new mosquito data, something like this, I can give another category to that, and that will be available over there. So say for example, right now without data it will not be possible, and then you can click on begin upload. So everything will be available in the data acquisition menu, which we had already seen in the last tab of this age impulse. Now next part is that if you want to create an impulse. So impulse, because of the company's name, they have given a label like create an impulse. But create an impulse means create an network architecture, network algorithm, create a training algorithm by which you will be able to train the model. And again, the beauty of this Age Impulse platform is that based on the data you have, it also suggests you that you need to do this sort of activity for training the data. So the best possible matching algorithm will be suggested to you. Okay, right now this is uploaded data. Up to this part, it's very easy. Everybody can do that. Now we will go to the impulse design section on the left bar, and there is a option of create an impulse. So let us go to that. Are you able to see this? Time series data, audio classification, output.
Yes, sir.
Okay. Now, right now, what I will do, I will delete all this. So whenever, as a beginner, you go to the create impulse section, it will ask you for the interesting blocks to add for your algorithm. Add an input block. So if I click on that, it gives me two options, whether you have images or time series data. So right now, the audio sound which I have used right now, I want to use as a spectrogram. Then this Age Impulse platform is suggesting me with a yellow star recommended that you should go with the images option. And if I want to go for the time series data, then there is another option. It suggests me that if you want to go for time series data option, then your data should be like sensor data, like vibration, audio data, etc. So I have both the options, but as Age Impulse is suggesting me to go for the image kind of an input block, I will add that. Okay, so I have added this. Now under the image also, I will get lots of parameters that what image size I want to create. I want to create a 32 by 32 image, or I want to keep it as a 96 by 96. What is the resize method? Again, I'm getting lots of options for that. Like if you want to resize to a smaller one, because if the information is too much low or very less, I mean to say, I need to create a very smaller image, because having a very smaller information in the image, if I create a resize of very big size, then it will not work. But anyway, just to understand that initially it is helping you to create the features from the data. Second part is add processing block. It again suggests me that you can use this pre-process and normalize image data and optionally reduce the color depth. If you want to go for the audio MFCC concept, extract features from audio signal using male frequency cepstral coefficient greater for human voice. If you want to normally use the MFE block, you can go for this. If you want to use a flattened model or a spectral analysis or a spectrogram, audio synthesis, raw data, etc. But right now it suggests me that I need to go for image or audio MFCC, etc. Let us select the second one. Right now as a beginner, we don't know anything, but we are randomly selecting anything. Then we need to see here that there are two different input axes, audio and image. Let us keep it as it is. The name is already MFCC, male frequency cepstral coefficient. And the learning block, we want to add as a transfer learning or maybe Kera's model for classification or maybe regression. But it suggests us that go for the transfer learning of concept of the image classification. Now it says me that output features are these for four types of data for Aegypti, wingwits, Peony, Q, and the RB type of mosquitoes. Everything is ready right now. So we have created some sort of architecture. Additionally, if you are a pro kind of a thing, or maybe you are a very much expertise, having an expertise in terms of all these parameters and features, you can add some extra processing blocks. You can add some extra learning block. But as a beginner, we are not interested in any advanced features. We will save these impulse and click on save. Okay, now once it is saved, we can go to the next part of MFCC, because we have created an MFCC block for male frequency cepstral coefficient. It is mainly used for audio frequency related data where it works with the male frequency component. And that is very much important for any of the audio data which is converted into an image or a spectrogram, and we want to do some sort of analysis or a classification using MFCC. So once it will open, I will go to the next step. So it is saved now. Let us go to the MFCC part now. I have clicked on MFCC in the impulse design section.
Sorry to interrupt you, sir, but your screen is freeze now.
It
I
is,
can see only
yeah,
say create impulse screen.
okay, I need to click on resume. Have you seen the previous one or not? I need to show it again.
Sir,
No,
if you
sir,
can
we did.
please repeat it.
Okay, let me go to the create impulse section again.
Yes, sir. Thank you, sir.
By mistake, I had clicked on pause screen, and that is why it was not, it was freezed actually. I had seen that message, but I ignored that. Okay. So here I was there, and I actually deleted all this and created again. I will create it again. So when you are in the impulse design section, you need to go to create impulse, and under the create impulse, it gives you that you need to fill up these four blocks to create a complete training algorithm. So add an input block, that would be your data, your images or audio sound or an accelerometer one. If you are not very much sure that what should I select, then based on the data which you have uploaded to the Edge Impulse platform, Edge Impulse will suggest you that this is recommended. So the yellow stars suggest that you should go for this. It would give you the best result. So let us select that. So it gives us an option that image data, having an audio or image data, or maybe this is the image size. If you want to change these parameters, you can change. Maybe keep it 32 by 32, 64 by 64, 96 by 96, 128 by 128, etc. If you want to resize the image, because maybe sometimes it is a very huge amount of data and very large size image, and some of the information is not useful, so we can resize the image and bring it to a smaller version. So these are the options which are available. Then we can go to the add processing block. Again, it suggests us that whether we want to go for image data, audio classification, audio MFE, flatten, spectral
Sir,
analysis.
one question, please.
Yes, please.
Sir, while reducing the size of image, will it impact the accuracy level in future?
It depends on the data type of data which we have used, madam. Say, for example, we are doing a kind of a facial expression classification. And if we have some images like, say, there is a group photo, or maybe I have taken my picture at the maybe at the bank of sea, or maybe bank of a river, and some of the information which is not required, I mean to say, I need to resize the image. We crop it the image. It's something like cropping or resizing, but usually it depends that you do not want much information in terms of processing, or maybe resizing the image will also help you to do faster. Like I have 1 crores of image, and if I keep all the image size as 1 MB, and if I keep it as 20 KB, then definitely it will do processing faster. That is what I personally understand and believe in terms of resizing the image. Whether it is useful to you, I don't know whether my answer is acceptable to you, but what I personally understand is that to do lots of data processing, we need to resize the images, because similarly it happens with geospatial images. Whenever a satellite data is being received, the file is of something around 4 GB of size, but we do resizing and rescaling of the image, and we bring it to some 500 MB or 200 KB or something like that. So we need to look at the hardware powerfulness as well as the software applications which are supporting the size of the image. That is also very important part. So
Okay.
second is the add processing block. We need to add the processing block. Is basically, again, you will come to know that what are the meaning of all adding these blocks into the network. If it is related to audio, go for this one. If it is related to sensor data, like go to raw data or a spectrogram when you are directly converting the data into an image. So let us select any one of these as an image. So I have added that. So second block is also added. We'll also add learning block. Which sort of learning block I want to add in terms of my project. So classification using Keras, or maybe transfer learning of using images, regression for Keras, etc. But right now it recommends me for the transfer learning. Okay, this is fine. As I told you that if you are a pro and you know something, or you want to do some sort of analysis, because while writing a research paper, yesterday somebody asked me that, like, how can we change this parameter? Is there any rule? No, there is no rule. Like, you add some block here and identify whether it affects your accuracy or not. Then you can do some trial and error. But right now we are not adding anything. We will simply save this, and the output features are also written here, that this is going to give you 4 different output features for 4 different types of mosquito wing sounds or wing bits. I have saved that impulse. Now second portion would be the MFCC, where I will be able to see that my sounds are converted into a spectrogram, and I will be able to check them visually also, that whether I'm getting any input feature or feature parameters for every single data which I have uploaded. So that can be an option which I'm going to explore now. So I will click on image on the left side menu under the impulse design. Recently, a month ago, somebody has created a very interesting machine learning project using this Arduino Nano, that he was able to identify the sound of a hot and cold water. मतलब आप एक ग्लास में गर्म पानी डाल रहे हो और एक ग्लास उसी ग्लास में ठंडा पानी डाल रहे हो. Similarity between, like, the difference between the sound of hot water and cold water, they identified using this Arduino Nano BLE33, and they collected data for those things. Initially they recorded the sounds for hot water and cold water, and finally they created those things. So right now I need to, okay, sample is missing image. as there is no image data into this. I need to uncheck that, and that is why it was giving me some error. See, this Edge Impulse platform, frankly speaking, cannot be covered in a 2-3 hours of session. But definitely, this is just a kind of a glimpse which I'm showing you, because there are lots of steps and lots of things we need to understand. But as a quick start, if you have any idea, if you have gone through this some steps, it will be very easy for you to start with, and it is not that much hard. But right now, I'm not covering number of things like which we need to keep in mind while creating a real machine learning project, because initially we need to do lots of setup for Arduino also. That I will cover in the slides. So whenever you will copy, you will get these slides. Definitely, it will help you to go through the steps. So most of the steps I have covered in the slides. So do not worry about that. But right now, in this example which I'm showing you right now, I may not cover number of things into that. Okay, now if I click on when I click on this drop down menu, it shows me whatever data I have uploaded for all the different mosquito sounds. These are all wave files which are visible in front of your screen. So I select any random file. Actually, I have done some mistake by adding an image part into that. But anyway, I will generate the features.
Sir, if possible, please provide some study material for this Edge Impulse.
Yes, it is there in my slide. All the steps are mentioned, and there is a very good documentation section on the Edge Impulse website. See, right now what I'm doing is that I took one sample and I actually started generating the features. I hope that everybody knows about like what are the features in a data. Features means various parameters of a data. Say for example, there is a house and we want to do a kind of a prediction for house price. Then house price may be dependent on various features of the house, maybe where it is located, and in which year it was constructed, maybe what are the different room size, what are the different facilities, what was the cost of like constructing house, etc. These are all basically known as features of a particular data when we are talking about a house price prediction. So in case of these mosquito related wing bits, we don't know what are the different features, but we have converted these audio samples into images by spectrograms, and we are generating some features. So at that time, we can go to the create and generate features, and it will generate all the features here, and finally we will get. Then we can go for the last stage. Right now, these steps are not, because they have not converted or turned into green sample, and that is why I'm simply showing you the different menus of that, because I have some problem in data right now which I have uploaded. Some unwanted data have been uploaded in terms of images with the sound. So if I remove them and I show you again, then it will work fine. Okay, now the final step is that transfer learning, which architecture, the training method which we have used. So in this, we want to set, by default, it suggests us that like number of training cycles would be 20. In the last example, I had told you about like difference between pen and pencil. If we are showing different pens and pencil for 20 times altogether, maybe learning rate is 0.5, data augmentation, neural network architecture. If you want a mobile net feature here, we can add into that. Choose a different model. It gives us that we want to use any other architecture like mobile net version, this one. All the different versions for different image sizes are also available. So it's all ready made in terms of a kind of a hint to you that you can switch to different. You want to change the output layer features. If you want to change the mobile net architecture, input layer architecture, everything, you can click on start training. So here it will start training for all these sections. copying feature from processing blocks, DSP blocks at the cloud level. It will start training at the cloud itself of the edge impulse, and it will do it for 20 times because there are some epochs which we have set. Or maybe you can change the number of training cycles here. And if you click on this, it will also give you a tooltip like number of epochs to train the neural network. Learning rate is basically how fast the neural network learns. If the network overfits quickly, then lower the learning rate. So it gives you a hint. Now it is done. Saving the best performing model. We have not got any accuracy, or maybe it's not at all any good model, but just to have an understanding of this, how the process takes place. It is saving the model, converting it to the TensorFlow. Look at these lines which we are getting here. It has converted the model to TensorFlow Lite model. It means that it has reduced the size also now. Profiling the model to float 32 model, because we may have number of parameters which are of floating point values, and that is why it is converting into a TF Lite model. Once everything goes well, we will be able to see that model is available, and we can finally retrain the model, or we can do live classification also on the cloud platform, or maybe we can deploy it on test here. See, it shows that job failed, no problem. So once what I will do is I will go to another project and I will show you a working model, working project, because by mistake I had selected another project which was, maybe I have uploaded some random data to that. But as we have some time constraints, definitely I will quickly go to that project and will show you that also. The problem is that the site is loading very slow, and that is why it is taking some time to load into my computer.
Sir, if you'll switch off your video, then it may be faster.
Okay, I will do that. Stop video. Okay, so here when I go to live classification, if I want to check existing things on my cloud platform on the Edge Impulse, either I can connect a device from where I'm getting the real-time data, or maybe I can use the existing device, I can use the sensor, and I can do start sampling or load sample, etc. And we can classify that. And the final step is deployment. It is not showing me. I need to switch to another project, otherwise you will feel that I'm not showing anything correct to you. Let me go to the project which is already tested. Okay. The best way to start with audio related data is that Google has a very good audio data set. If you can download that audio data set, it gives you all sort of sounds which are available in the world. And maybe if you are interested in birds data set, bird sound data set, there is a very good Google data set which is available for bird sounds. So it's a very huge data set. We cannot classify and we cannot train all the available data of the birds. But what you can do is that you can download some bird sounds, like maybe a sparrow and a peacock and myna, or maybe cuckoo, and download all these 4 different bird samples and upload these to Edge Impulse platform and classify them. So right now, this is the example where we have everything is right. I mean to say, create an impulse is also okay, and MFE is also fine. I want to show you the real-time training which happens on the Edge Impulse platform. So these are already the things which we have seen so far. Neural network classifier. This is related to sound, and that is why it shows me a window size and everything. Because what happens practically when maybe our data samples were of say 10 second or 10 millisecond, and if we use the microphone and if we are capturing the real sound, we need to specify that how in how much seconds we want to capture that sound, because it is simply like a shutter of a camera. If you open the shutter for a longer time, then it is not going to give you much information in terms of like maybe a full white bright light into your image. But based on the shutter speed, similarly we set the window size for audio signals to capture. Okay, so whenever we do some sort of training and everything, we get something like a confusion matrix. These are all the sounds for birds which I was talking about, like Asian quail and laughing and rose ringer or square or noise and everything. So whenever we are talking about the audio samples and whenever we do a training kind of a thing, this is what we get in terms of accuracy. So in this example, it is 95.9% accuracy after training the model. Here you can see that there is an input layer of 7,968 features. And whenever we do some sort of training and all this, it shows us this sort of 3D view of all the data which has been trained and classified. It also shows us that inference, the peak performance, flashing time into the memory. So those who are in terms of research and want to write a very good research paper, all these data can be very useful for including in the paper, that you can show the real-time view of all the data samples. Say for example, if I click on any of the data sample, it shows me that this is of Asian quail 25 PKR42C is the name of the file which was uploaded as a data sample, and it is going a little bit outside the cluster. So maybe this data can change your result. So you can remove even, or you can test and you can see the features of this data also. Here you want to see that like these are the included by default layers into the architecture of this. So here you can go and reshape layer. You can edit that, change from 32 to 64 number of columns into the layer, or maybe you want to see the code, how it is generated. Click on these three dots and go to the switch to Keras expert mode. You will be able to see that a complete Python code is generated, and you will be able to use that for computers. You'll be able to use that for other hardwares also. If you are using Edge Impulse platform, there is no need to even look at the code, because everything is ready-made in terms of model and everything. It even gives you a firmware at the end of the creation of the project. I feel that right now it is little bit complex for everyone to understand, but once you will try at your own, you will definitely be able to understand. So those who have already done some work in terms of neural network architecture can see that these are standard program code flow, that initially we import the libraries and we define the TensorFlow model and the architecture of the model. Here is a sequential architecture. This is basically the different input and hidden layers which we are adding into this, and what is the final layer, that is a kind of a flattened one. What is the classifier which we are using here, that is Adam classifier having all these parameters. Batch size is 32. So the code is generated here, and you can do the same training again and again, and you can improve the version. Okay, now up to this part, even whenever you are writing a paper, you need to add the confusion matrix also. Confusion matrix is basically shows you that for which type of data, how much accuracy you are getting. So if you look at this confusion matrix and look at the Asian quail kind of a label. So for Asian quails, whenever it was given as a data input for testing, it was giving you 98.6% accuracy. And for others, it was almost like it was making a kind of a false assumption for rose ringed and square-tailed trongo is a kind of a bird, the data which has been taken for this sampling or maybe for training. So it was only giving me some false data when Asian quail was given, and it was predicting as a rose ringed kind of a thing. So it was only for 0.7% of data, but most of the time it was accurate. So looking at the laughing cuckoo or maybe rose ringed, and everywhere you will be able to see that those green square 98.6%, 98.6%, 91%. So now here we can understand that for rose ringed, the model has not performed well as compared to Asian quail. but it was great for square tangled bird. It was 100% right. Not a single sample was predicted as a false data. So this confusion matrix is very much important. That gives you that which are the samples are basically responsible for giving you the best result, or maybe which are the samples which are making your model little bit lower in terms of prediction. Okay, up to this it was fine. Now we will go to the deployment section. Live classification, retrain model are again to reiterate the model or maybe refine the model. You play with some parameters, change those parameters and try to see whether it affects and change the accuracy or maybe change the confusion matrix, etc. Or maybe the accuracy of the prediction. If it is not giving you any change in that, so it means that there is no use of changing those parameters again and again. Okay, now deploy your impulse. They call it as an impulse, but it is basically the model. So we have these options like C++ library. If you are interested in creating your own C++ library using this model, you can do that. This is for Arduino library. So what is Arduino library is basically like whenever we are using any of the sensors or maybe any device, GPS, GSM or accelerometer, we have seen that we need to add those libraries into our program. So import like spi.h, import wifi.h, etc. So here, whenever we will create the library for this bird sounds, it will create a header file basically. So whenever we will download this header file is nothing but our AI model, a machine learning model, which we need to include into the header file of our Arduino program. So that 8 KB or 10 KB of header file acts as a AI or a machine learning model in the hardware. This is for NVIDIA boards. This is for WebAssembly. If you want to create a website and a JavaScript and you want to run the model on the browser itself, then this WebAssembly is a good option. If you want to build a firmware directly, so you don't want to write a program, but you want to run ready-made firmware. So it will flash your Arduino firmware and it will load the firmware with the Arduino code and everything. You need not have to write anything for the Arduino code. It will directly be flashed into the Arduino and it will work directly. So building a firmware for all these hardware platform is also available. Recently, they have included the Sony S Presence board. This is a very interesting board. If you can get it instead of this Arduino Nano, it would be a very good choice because it has a camera also, inbuilt camera. And Linux boards, any Linux development board will work. Now, if you create on build, you need to select first. Say, for example, if I click on Arduino library, I want to build. I need to select that. And later on, it will show me that if you will create an Arduino Nano header file, the size of the model would be something around 8 KB or something like that. Let us see and build it. If I click on building, now it is building the header file, converting the model for Arduino into a header file, and it will be ready to download. So I can use that header file directly into my Arduino's IDE. I need to add that. So now it is ready. It has been available as a download option. See, now you can see that it has been downloaded, EI curated 10 second of MFC. यहाँ पे model भी आ गया. You can see here it is example code is also available. मैंने यहाँ पे देखा कि like I have a microphone code for continuous or an accelerometer microphone. I need to open this. If I open this, it has created an Arduino code for me also. So it will be ready to deploy directly into the Arduino board. आप यहाँ पे देखिए, it has already included something like curated 10-second MFE Inference.h. This is the model, which is also available in the downloaded file. TF Lite. This is the model. This is the header file, which is already available. The size is 1865 bytes. पूरा का पूरा प्रोग्राम भी रेडी है. सीरियल बिगिन मतलब माइक्रोफोन जैसे शुरू होगा, इट विल डिस्प्ले सम मैसेज एज इंपल्स डेमो एंड इट विल बी कंटिन्यूअसली लुकिंग फॉर द बर्ड साउंड्स. जैसे ही कोई बर्ड्स की आवाज आती है, इट विल क्लासिफाई दैट, but it will classify only those 4 birds which we have included as a sample. Look, there is no need to write anything. There is no need to write any code. It gives you everything. But now, as a researcher, you can take this code as a reference. You can modify that. You can add number of parameters, number of other codes, because everything is open source right now. So you can use it and extend it for other purpose. Now coming back to the Edge Impulse platform. आपने ये Arduino आपको दिख रहा था कि नहीं? मैं यहाँ पे मैंने स्क्रीन शेयर किया था, आपको दिख रहा था कि नहीं?
नहीं सर, नहीं सर।
अच्छा, मैंने पूरा स्क्रीन नहीं शेयर किया है। What I need to do? Stop sharing. Let me share everything. So whenever I build and it get downloaded automatically, I got this zip file. So if I open that and go to this file, this one, it gives me an example. Matlab, it has created example for microphone continuous. Matlab, there is a difference between microphone and microphone continuous. Means you want to create a real-time system by which it is always looking for some sound. So it is continuous one. So if I open that and if I click that on the code, it will open an Arduino IDE and it will show me that what code has been generated automatically by the Edge Impulse platform. Initially, you will see that we need to include the header files. So this is the header file which was created by Arduino IDE. This header file is nothing but a machine learning model for all these 4 birds different sounds for to classify using Arduino Nano. एंड सब कुछ यहाँ पे लिखा है, मतलब कौन से बोर्ड रेट पे ये काम करेगा, आपका कौन सा इन्फरेंस है, कितनी सेकंड का वो इंटरवल ले रहा है. सो ऑल दिस पैरामीटर्स वी नीड टू सेट फॉर दैट मॉडल. सो समरी ऑफ इन्फरेंसिंग सेटिंग्स. आप कोई भी कोड में देखिएगा, जो भी मशीन लर्निंग का कोड है वो हार्डवेयर के लिए जब आप लिखते हो, you need to provide all these parameters. So these are a kind of a by default code. You need to simply change the values. आप इसको बाद में change भी कर सकते हो कि आपको मतलब ठीक नहीं लग रहा है कि okay, I want to keep it for 16 seconds, 16 milliseconds or 15 milliseconds, etc. You want to give some different message. So यहाँ तक तो ठीक है, चलो ये हम यहाँ पे देख लिया है, लेकिन अब जाएंगे हम वापस इस पे. डिप्लॉयमेंट हो गया. एक डेमो दिखा रहा हूँ जिसको मैंने लोड किया था. द सेम एग्जांपल व्हिच इज अवेलेबल ऑन द एज इंपल्स वेबसाइट. This is the video. I don't know whether it will be audible to you or not. Hope it is visible to you.
Yes sir, it is visible, but not audible.
Audio was audible or not?
No sir, audio was not there.
Is it audible now?
No.
No sir.
No, sir.
I don't know why it is not there, not audible, because there is no option I am able to find in the WebEx platform by which I will be able to share that audio. Anyone can tell me how to use the system sound?
Sir, in your that mute unmute tab, there is one drop down.
Okay, yes, got
You
it.
just click on that, and there are some options.
WebEx Smart Audio, microphone, USB, speaker, headphone, use system settings. I use that only. You
Yes,
are
sir.
listening.
Already it is ticked, I think.
Switch audio. Anyway, उसमें क्या था कि जो मतलब I was sharing with you was cuckoo sound. मतलब जब भी कोई मेरे घर से बाहर बाहर जो पेड़ है वहां पे कोई कोयल की आवाज आ रही है तो it was displaying the image of a cuckoo and another was Maina. If it is not available, it was showing me that Maina is not singing. मतलब मैंने एक ही डिस्प्ले किया हुआ था उसमें कि जब भी उसकी आवाज आती है तो उसका फोटो डिस्प्ले होना चाहिए. So I can have identification of bird sounds using the microphone on the board and it was displaying the image of that. If it is not there, then it will display kind of a text message. That was a simple thing which I modified later on to this code and I added the graphics of those birds into that and the similar or the same code were used for that one. That is what the intention of showing you that demo. Okay, now coming back to the another part, I need to do it quickly from Java. Okay, so coming back to this, Edge Impulse पे हमने देखा like we need to go to the Edge Impulse platform, collect the real world sensor data, train machine learning model on this data in the cloud, deploy the model back to your Arduino device. That was a very simple process. This was a kind of steps which I have already taken as a screenshot. Create a new project, select the screens, select the options by one dashboard and devices and data acquisition. Select any of the options initially. If you don't know, it will recommend you. Yes, this is very important. Like as a beginner, if you want to set it up for the Arduino Nano, then initially you need to go to the Edge Impulse command line interface setup. अभी इतना ज़्यादा ज़रूरी नहीं है because like everybody may not be having this Arduino Nano, but this is very important. Otherwise, it will not connect your device with the Edge Impulse cloud. You need to download that, install and dependencies, and finally you need to run the command line for Edge Impulse into your MS-DOS prompt on the computer. What are the things you need on the computer is that you need to have a Python 3 on your host computer. You need to install Node.js version 14 or higher. Install other dependencies when prompted. And finally, you need to install the command line interface tools via npm install -g Edge Impulse CLI force. That will help you to keep it ready for this. From where you can find out Arduino CLI. So you can go to Arduino's website and you can find out command line interface based on your computer's platform, whether it is Linux or maybe Windows or a Mac machine. Python, you can get it from the Python 3 website or Python website. And this is one of the first step, how you can connect the data from the web browser. Gesture to text using machine learning. So this is an example which I'm going to show you now. And that will be a totally different platform. Right now, I'm not showing you Edge Impulse platform, but I will show you a very root level or basic level data collection and directly how we can create a machine learning application. The concept fundamental remains same, but the method is totally different. So we have installed all these libraries and now we will see. Okay, now let me switch to the Arduino's IDE and I will show you this. Stop sharing. Csv file. Okay, are you able to see the Arduino image IMU record file on your screen?
No, sir. Screen is not sharing.
And now I have shared the screen.
Yes.
So this is right now what I'm going to is that this is again a ready-made example. by Arduino B3033 Nano. Whenever you install that board, it will be available with that. You can record or you can get the sensor data. So this is a very simple understanding of the code, that it captures the accelerometer data. Accelerometer is basically a motion sensor. It gives you acceleration and movement of the sensor in X, Y, and Z direction, and with the acceleration value. It is basically a MEMS sensor. Whenever there is a change in the capacitance between MEMS plate inside the sensor, it creates some voltage or maybe resistance kind of a thing, and basically you get that as an output. So we need to set some baud rate of the sensor whenever we are connecting. This is the library which we have included, because in one of the slide of Arduino, we have seen that whenever we want to use the sensor, we need to include those libraries. And this is the library for accelerometer, because we have an LSM 9DS1 as an accelerometer, 9x IMU into that. What are the different data we will get is that we will get acceleration in X direction, Y direction, Z direction, gyroscope or orientation value in terms of X, Y, and Z direction. So these are the three things we want to print, because whenever we will get the data, there should be a label on top of that. IMU is a kind of a function which is available in the library itself. This one, Arduino 9SM9DS1.header file. So if it is available, because initially we are checking with the condition that if this acceleration is available, read the acceleration data from this particular function, read acceleration AX, AY, and AZ. We want to do some absolute value calculation, because as it is given in the data sheet directly. If you don't do that, even though there is no problem in the beginning, but as they have already given us that you need to do some sort of absolute calculation to remove the errors or maybe any errors due to the calibration. Not falling into all this complexity, right now our main aim is to collect the acceleration data. Whenever I move the sensor, I should get the acceleration in my Arduino serial monitor. Okay. Similarly, we have a gyroscope value. So if it is available, we will be getting those values, and finally we will print this on the screen. So AX, AY, AZ with a comma separation, and GX, GY, and GZ as a comma separated value, and we are printing those values. So if I upload this code into my Arduino Nano, which is connected right now, what I will be getting, that let us see. I have uploaded this, click on the upload button to the Arduino. So right now it is being uploaded, and you can see that right now it is being compiled. It will be uploaded and the program will start running. As compared to the other Arduino boards, this Arduino Nano 33 takes few seconds more to compile and to load the program. That is what the observation is all about, but for the first time only. Later on, once you do it again and again, it will do very fast. But for the first time, specifically for machine learning model, it will take sometimes 10 to 15 minutes also. So you need to keep patience with that. Sometimes you feel that it is not working. It started uploading now. It is done. Now let us go to the serial plotter. Is it visible to all of you, serial plotter? White screen?
Yes, sir.
Yes, sir.
Yes, sir. Yes.
Okay, now what I'm doing is, I have this Arduino in my hand. As it has inbuilt accelerometer on board, now I will do some gestures. Say for example, I am doing a circle or maybe a 0. 1, second, third, fourth, fifth, sixth, 7, 8, 9, 10. I have done it for 10 times. Now you can see that there are some similarities in the gesture which I have done. No doubt there is a change in the value of these legends, what we are able to see on the screen, that AX is basically blue, AY is red, AZ is green, GX is orange, GY is lavender, or GZ is gray. Now if I'm doing a gesture for 2, it is different than 0. Now if I do a gesture for 7, you can see that there are some similarities among them. Most of the time you will be able to see that you can identify that these are all similar, not exact one, but there is a you can say that that's some sort of similarity in terms of shape. If I do gesture for 8, it is different than 7. But again, all the gesture for 8 are similar. If I do maybe like some sort of activities like moving it on the left side quickly. If I do it on right side, okay. So when we visualize this data, it becomes very easy for us that there is a similarity in all these gesture. Now, if I do it by my own self, myself, if I give it to someone else, and if I tell him to do this sort of gesture, again you will find that there are similarities. Somebody will do a 2 in terms of very smaller scale. Somebody will do a 2 like this. Then there is a difference, but we need to collect a variety of data. Now, if you look at the values, say for example, I'm going to the serial monitor part. All these are values which are visible on your screen are for different gestures. I'm doing 2 right now, creating a gesture for 2. So by looking at this data, we can never identify whether it is a gesture for 2 or not. Either we need to go to some data analysis tools, either we need to plot them, or maybe we can do some sort of take a help of Tableau kind of a software, or maybe we can transfer this data into an Excel sheet and we plot some graphs. We find out some mean and variance and median values and find out some sort of similarities among them. Or we can do some sort of clustering of the data, whether they are into a similar cluster or not. We can do some sort of KNN classification, nearest neighbor classifications, and something like that. But right now, our main job is that we want to create a wearable device by which we are able to identify some sort of human activities. Human activities like whether we are walking, whether we are running, whether we are jumping, whether we are eating, maybe we are throwing something like that. So we need to collect the data for that sort of activity first. What we are doing here is that we are creating a gesture for creating some sort of numbers like 2, 3, or yes, no, or maybe doing some sort of push, or maybe a kind of a punch and flex. If I do something like this, it's a punch. If I pull it, like it's a flex, or maybe doing some activities like this, or maybe throwing to some direction, I'm getting some different values of this sensor data output. What we need to do is that to collect the data, initially for doing the gesture, we can go to serial plotter. We can see that are there any difference in the pattern, whether the patterns are similar for a single gesture. Maybe there is a minor variation in the peak values of the data. That is fine, that is accepted. But overall, the combination of AX, AY, AZ, GX, GY, GZ is almost similar in all the similar patterns of the gestures. Now, once we do that, what we need to do is that we need to create a CSV file. First of all, we need to go to, let me delete it and clear it, and then I will show you. I'm clearing the output. I'm resetting the board. So whenever I do it for the first time, it will give me that label first. Okay. Look at the first line. It shows me AX, AY, AZ, GX, GY, and GZ. So first value 0.511 is AX, AY is basically 0.341, AZ is 0.726, minus 954, minus 1.931 for GY, and for GZ it is minus 116.44455. What we need to do is that just Control A and Control C, copy them, go to some text file, paste it over there, save that file as a CSV and give some name like 2.csv. If I have done this for gesture 2 like this, I need to give the file name 2.csv so that I can understand that the data which I have copied into the CSV file is for gesture 2. But now in the previous lecture, I had discussed that more the data, more the truth you have, more the accuracy you have. So if I do a gesture for 2 only once, or maybe for twice only, then it is not going to give me a very good classification. But I need to record the gesture for 2 for say 30 times or 40 times or 200 times or 300 times. I need to do that gesture again and again. And even I should not be the only person who will record all these gesture. I should give it to someone else also. Maybe to another, my friend, or maybe the colleagues in the office, I need to give it to them. And finally, they will also do this sort of gesture and I will have to record all this data. But there is a single file for gesture 2, that is 2.csv. Now I do gesture for 3 or 4 or maybe for all the digits and I record a CSV file. But what is the important thing I need to keep in mind, that if I have say 20,000 rows of CSV for gesture 2, then I should expect that for all other digits also I should have 20,000 samples or 20,000 rows in the CSV file. 2.csv contains 20,000 rows. 3.csv contains only 10,000 rows. Then there is a mismatch or imbalance of the data. So we need to keep in mind that there are variety of data collected. There are almost similar data in terms of numbers of the samples. Again, like for example, for 2.csv, if I am the only person who has collected all the 20,000 samples or 20,000 lines of data at my own, and for 3.csv, there are 10 persons who have created 3.csv gesture and created 20,000 samples, then there is again a mismatch. Mismatch, I should not say, but there is not a kind of a uniformity of the data, because for one gesture, it is only the one person who has created that gesture, but for other gestures, many people have created those gestures. So try to keep a balance among the data creation. Once you create all this data, we need to go to the section for, there are two options. Either you can upload this CSV, like go to Edge Impulse, upload the data, give the label as 2, gesture 2, and upload that 2.csv into the Edge Impulse. Then upload the 3.csv or 4.csv and do the same training process what we have done so far. Another option I would like to show you here is that another option is this one. So I was talking about that, pick up the Arduino Nano BLE Sense and move it. Here I have given an example of punch and flex. 10 times I have done that. Serial monitor, I have got all this data. Copy those data into an Excel file. Now there is an option that you can go to Google Collaboratory, because you might not have set up your computer for machine learning projects and everything. So there is a direct option that you can upload all this data to Google Research Collab. And on that, there is always an option that every library, every software is available to install. So if I click here, I will be directed to Google collab.research.com. If you have a Gmail ID, you will get access to this Google Colab. And this is the example which TensorFlow has already given. So that example will open into a Jupyter Notebook file. Jupyter Notebook is basically a web-based Python interpreter, or maybe you can call it as an interactive Python notebook, where you do not need any Python installation into your computer. You can write the program into the browser itself. You can run the program over there in the cloud itself. So this is the example by Arduino Sandeep Mistry and the Dan which I talked about. So they have given the example that if you upload the data of this punch and CSV, punch.csv or flex.csv, in our case it was 2.3 CSV, 3.csv, 4.csv. they have written the code here that what are the different things we want to get from the accelerometer data, AX, AY, AZ and everything. You run these all the samples one by one, and finally you will be able to get a header file at the end of the code. Right now, it will take too much time if I will upload the samples here and again do the training over the cloud. Similarly, at the end of this, we will get a header file that will be a .h file. We need to download that header file. Similarly, what we had done in the Edge Impulse platform, we had downloaded the header file and we have copied into the Arduino Nano and written a code for that. The code was already generated by the Edge Impulse platform. Similarly, we have here a code for the Arduino Nano for classifying the text. So not taking much time, I will move to the Arduino platform where I already opened that code of classifying that thing. And you classify. Okay. So now when I download that header file from the Google Cloud platform, it will be stored somewhere in the download folder as a model.h. Now look at here in the second tab of this Arduino code for classifying the gesture 1, 2, 3, etc. I am ABC. I have shown here ABC here for gesture, means I have not gesture for 2, 3, 4. Yes, please.
Screen is not visible, sir.
Screen is not shared.
No, sir.
Okay. So I opened the code now in Arduino for classifying the gesture. Previously it was for recording the data. If I open that record file, it was for recording, which I actually uploaded on the Arduino Nano, and we had seen those graphs for different gestures. But once we have recorded those gestures, we have uploaded to either Edge Impulse platform or Google Colab, and we have created a header file that is our model. And now we have downloaded that model into our computer. We can write a code for classifying the gesture, because now it is another part. We use the Arduino Nano for recording the data of sensors for gestures. Now everything is done. We will download the model, and now we will write another code for classification. We will use the same method to identify the sensor data, but now it will pass through that model, and that model is here. That is model.h. So this is the file which contains the logic or mathematical calculation for gesture like A, B, C, etc. Okay, how to add this model here, model.h, is that go to the sketch, add file, and select that header file wherever it is recorded. So it will come into this second tab of the Arduino's IDE, model.h, and you need to write that model.h file into the code itself. यहाँ पे लिखा है like include model.h. That is the machine learning model. It's a header file basically. Now what we want to do is that we will transfer this code into the Arduino Nano, and we will see that whether it works perfectly or not. So it is being compiled right now. जब मैंने ये किया था उसमें I have recorded for A, B, C, etc. Because during this session, if I will start recording, I need to record it for say 200 times, 300 times for every gesture. So I had already done and prepared that model, uploaded to the Google Cloud, run those training algorithms, and finally it was available over as a header file. So I'm directly showing you the output of the code. So, but I need to install that code into the Arduino with that model. So model will also be get loaded into the microprocessor chip, the memory, or the I need to say flash memory. Is being compiled right now, and it will be loaded. Done. Now what I need to do is simply I will go to the serial monitor Let us hope so it should work. I will do the gestures for A first of all. It shows me C. I need to do it perfectly. Okay, now it shows the result is A. Result is A. Now I'm doing B. It's not doing well. C, I think it will work fine. Or maybe if I have given a wrong label to those data, that I have given a label of C to A data or maybe A to C data, then again it will give you. It is something like whenever we do a dog and cat classifier, and if we give the label of cat to all the dog data, then definitely it will classify like that only. But here it works fine. I mean to say for B it works fine. It is always having some sort of latency also. So maybe it is not perfect one. Whenever I'm doing the gesture, it prints the previous one actually, and that is why it is taking time. And you can see the accuracy also. Like if I do C, it shows me the accuracy. Actually, I need to do it for some. Wherever I'm getting the highest accuracy means that that particular gesture will be printed. So in this case, this is just a proof of concept for creating gestures using machine learning and identifying those gestures. The process is something like initially you need to understand the data, you need to understand the sensors, you need to understand the behavior of the sensor, collect those data. Right now we were only targeting the accelerometer. From the accelerometer, we had collected only few data. Even the data samples were not sufficient enough. Right now, I think for this example, I might have taken 20 or 200, I'm not sure. But this was the samples which were collected. The data were uploaded directly using the standard model or the algorithm for the training. And we have got some sufficient accuracy for classifying those things. So whatever gesture we do right now, it is able to predict those gestures. So this is a kind of a proof of concept for showing you the concept of edge computing or a machine learning on any Arduino device. You can use any of the other platforms which we had discussed so far in the 2 days session, and any one of them will work fine. It depends on your expertise on the hardware, your expertise on the programming language. If you are very well versed in Arduino programming, then this is one of the best solution. If you are having a very good command over Python, you can go for Raspberry Pi also, or maybe you can use another platforms which are available so far. So this was all about like maybe within two different sessions, I tried to cover or try to give you as much as I can, and maybe it was something like a bird's eye view. It was not that much in detail because it is not at all possible to cover everything line by line in terms of code and line by line in terms of I mean to say every aspects of the demonstration which I had given you so far. But this will definitely help you to start with, or maybe you can at least guide your students and maybe give some guidance and instructions to start working on this area. So there are n number of ideas which you can utilize and use for your creativity, and you can make some very good application, or maybe you can use some use cases also. So uh, floor is yours now, and you can start working on any of the area in which you are interested. I will suggest you to explore Edge Impulse platform. I will also suggest you to explore Arduino Nano 33 BLE Sense. That's a very beautiful one because most of the sensors are on the board itself. There is no need to interface them, and there is no need to use a breadboard and Arduino and everything all together. A single USB connectivity, and that's all. And finally, if you connect a battery with that, you can make a wearable one and you can do lots of activities. But remember one thing, when these big companies are making the products, they are collecting the data for few months with different types of subjects in different conditions, different activities, and they have a variety of data. And that is why their performance, their accuracy is very high in terms of all these activities. As a faculty, like whenever we do something, we do not look at all the wider aspects of the application, and that is why we may face some sort of problems in terms of accuracy, or maybe sometimes it is not giving you the accurate result. That happens. But when it is in terms of a product, we need to look at various aspects of the parameters for highest accuracy. So I think I tried to justify the 2 days of different sessions on Arduino and machine learning and age impulse and number of things which I discussed so far. I tried my best to give you and maybe to try to explain you. Maybe at some point of time I may not be helpful to you in terms of explaining you well, or maybe I might not have covered in detail. So please excuse me for that. I think it would be helpful to you as at least just to have a good beginning of the machine learning on the hardware. Thank you so much, madam.
Thank you so much, sir. Friends, if you have any question, you can please ask. किसी को कुछ पूछना है?
I think they all are overloaded with today's.
That's a nice demonstration,
Hello,
sir.
sir. Hello.
Yes,
sir.
please. Yes, please.
So you have actually taken us to a wonderful journey of a new generation intelligence.
Thank you.
Thank you very much for such a lovely session, sir. Actually, I was
Thanks.
literally visualizing the amazing world this technology is capable of creating. I'm very much actually excited now to know a little more about some of the research projects on which you have worked. And secondly, one more thing which I wanted to know was how we can use this technology in our domain of higher education also.
Yes.
So if throw some light on this, it would be really nice, sir.
Okay, like if we talk about various research topics, like in our day-to-day life, in our everyday life, we see lots of problems, but we never look at them. Very simple, like there is a fan on top of my head. It is since 100 years, but we are not able to still replace it completely. Second thing is like, see, we have a pressure cooker in our home. Every day in the morning, my wife tells me that count the whistles. I'm going to this work and I need to count them. मतलब 3 से ज्यादा हो गया तो बोलेगी ये इतनी कब से ये बज रहा है ये सब. So these are some of the problems we are every day facing, not facing, but we are like living our life with those problems. They are not actually problems, but we need to have some sort of solution. When the technology is advanced so much like anything, we can find out that there are thousands of problems around us, and we can at least try to solve some of them out of this using this technology. So say for example, whenever we have kept a bottle under some say tap, it is being filled up, maybe from 0% to 100%. At every level of water, the sound is different. मतलब हमको तो मालूम चल जाता है एज ए ह्यूमन बीइंग, हम मतलब उल्टे खड़े हैं फिर भी मालूम चल जाएगा कि हाँ ये बॉटल भर जाने वाली है, अभी ज्यादा थोड़ी देर मतलब खड़े रहे तो ये आउट ऑफ मतलब बाहर निकल जाएगा पानी. सो आई ट्राइड विद दैट थिंग ऑल्सो कि मैंने एक जगह पे ऐसा किया कि बॉटल के पास में ये आर्डुइनो नैनो रखा. 10 mm मतलब 1 इंच तक पानी जब बॉटल में भरा तो मैंने उसका साउंड रिकॉर्ड किया. फिर 20 मतलब 20% फिल अप, 30% फिल अप हुआ, 40% अप टू 100%. आई टुक वेरियस सैंपल्स ऑन दैट और फिर मैंने उसको टेस्ट किया. मैंने ऐसा सोचा कि जब 95% हो तो ये स्टॉप हो जाना चाहिए. मतलब just by looking at the sound of the water which is being filled up in the bottle, we are able to stop that. So similarly, we can find out lots of solutions in terms of various activities also. Like whenever I'm riding my cycle, every day I go for cycling for 20-30 kilometers. So in the morning, I see that like if my speed is at this level, or maybe my GPS data is showing me that which I'm getting, how can I use machine learning for that? So there are lots of activities and like problem statements we can find out in day-to-day life that can help us in bringing out the solutions for them. और जब भी कोई solution आता है तो हमको लगता है कि अरे हाँ इसने कैसा इनोवेटिव चीज बना दिया, कैसा क्रिएटिव कर दिया, बट these are all very small problems. मैं आपको एक एग्जांपल देता हूँ जो मैंने आप जब आज ये दिखाया था आपको कि it has lots of sensors into that. So my daughter recently joined MS in data analytics engineering. So in final year, she was also working with this one, and we were discussing about number of parameters and sensors and machine learning algorithm. So she was able to give me a very innovative idea based on that, and I was very much impressed with that. And even I had also contributed something to that, and she filed a patent on that. So how it was that this was the gesture right now I'm doing, but can we create a kind of an encryption methodology or encryption and decryption technology using this one? कि मैंने यदि इसको नॉर्थ साइड में 2 किया और मैं यदि इसको साउथ में करता हूं तो ये नहीं चलना चाहिए. मतलब इट इज माय पासवर्ड. से फॉर एग्जांपल मैं यदि उत्तर दिशा में मैंने खड़े रह के 2 लिखा तो दैट में बी माय पासवर्ड. Okay, I want to create some kind of a unique encryption code in different directions of like using the magnetic field of the earth. तो encryption करने के लिए we use the earth's magnetic field sensor data as well as the gesture data and number of things all together. We combined them and finally we filed a patent based on that. So a very small device, very small concept can even lead to you a kind of a very interesting patent also. सो बहुत सारी चीजें हैं आप कर सकते हो मतलब इट इज ऑल डिपेंड ऑन द क्रिएटिविटी और द इनोवेटिव आइडियाज वी कैन इम्प्लीमेंट यूजिंग दिस वन. यूजुअली लोग क्या बोलते हैं कि अरे भाई आर्डुनो पे काम कर रहे हैं ये तो बहुत छोटी चीज है, थर्ड सेमेस्टर और फर्स्ट ईयर वाले बच्चे यूज कर रहे हैं. But if you look at the MIT projects in Media Lab, most of the projects are based on Arduino because they do not consider that this is a very low level device of a kind of a thing. It all depends on the creativity what we are using to innovate something. We need a simple platform, we need our creativity and number of things to solve the problems all together. और दूसरी ऐसी बहुत सारी चीजें हैं जैसे कि मैंने कल ही एक अपने स्टूडेंट को बताया था कि लाइक कैन यू ट्रांसफर योर डेटा यूजिंग मशीन लर्निंग टू some level when it is found that it is your voice only. I mean to say, like, say, for example, I'm trying to generate my own voice using machine learning. Is it possible? And can you identify that whatever voice we are getting in terms of telephone calls is the real voice of the person or it's a recorded voice? So people use it in forensic also. People use machine learning, people use AI in forensic science laboratories. In Gandhinagar, we have a National Forensic Science University of India. They do that sort of activities and all these AI technologies to identify whether it's a real sound or maybe a fake sound or a recorded sound or something like that, or it's a mixture of those things. अभी recently आपने देखा होगा कि like people have tried to paint those older photographs using machine learning technologies. मैं आपको एक 1970s का अपने घर का एल्बम निकालिए, उसमें से जितने सारे ब्लैक एंड व्हाइट फोटोज है आप उसको लीजिए. अब हमारे दादा ने उस दिन कौन सा कलर का वो कपड़ा पहना था हमको कैसे मालूम चलेगा? मतलब हमारी नानी की नानी थी, उन्होंने कैसी साड़ी पहनी थी, कौन से कलर की, हमको कैसे मालूम चलेगा? बट पीपल हैव ट्राइड टू रिवील दोज थिंग्स ऑल्सो कि अभी आपने क्या किया कि लाइक यू टेक फोटोग्राफ्स ऑफ ऑल द कलर इमेजेस ऑफ योर फैमिली. उसमें बहुत सारे लोग हैं जिसके अलग अलग कलर के कपड़े पहने हैं. यू कन्वर्ट देम ऑल देम इनटू अ ग्रे स्केल और अ ब्लैक एंड व्हाइट इमेज. देन आइडेंटिफाई द पिक्सल वैल्यूज एंड क्रिएट अ मॉडल कि हाँ ये ऐसा ब्लैक एंड व्हाइट फोटो में ऐसा है तो इसका मतलब ये है कि ये ब्लू कलर का था, ये रेड कलर का था, ये ग्रीन कलर का था. उसको फिर से रिवर्स किया और पुराने फोटो को अप्लाई किया. इट वाज एबल टू जनरेट अ कलरफुल पिक्चर्स ऑफ दोज टाइम्स व्हेन देयर वर ओनली ब्लैक एंड व्हाइट कैमरास. सो मतलब बहुत सारी चीजें हम बैठते हैं तो लाइक वी आर एबल टू डू एंड इनोवेट नंबर ऑफ थिंग्स. इट्स ऑन एंड ऑन, लाइक देयर इज नो लिमिट ऑफ दोज थिंग्स.
Wonderful,
इसका
sir.
मतलब
Very wonderful, sir.
हेलो सर,
यस प्लीज.
इसका मतलब उस सब कलर के लिए अपने को बनाना पड़ेगा पहले और वो अप्लाई करना पड़ेगा अपने
नहीं
original
बना,
image
ये
पे।
मशीन लर्निंग मतलब एआई का फायदा ही यही है कि वी नीड नॉट हैव टू like write a program. We just blindly give all the parameters to them and let it calculate, give a model directly. मतलब हम क्या करते हैं इसमें, हमने तो कुछ देखा नहीं था कि कौन सा सेंसर का डेटा क्या था. हमने तो सिर्फ ऐसा ही बोल दिया कि ऐसा कुछ है तो ये 2 है या A है या B है या C है. हमने कुछ नहीं देखा था सेंसर के अंदर. हमने तो सब डेटा कलेक्ट करके उसको दे दिया और उसको बोला कि चलो मॉडल प्रिपेयर करके दो. मतलब इट कैलकुलेटेड ऑल दी आंसर्स फॉर डिफरेंट जेस्चर्स. सो दैट हैपेंड इनसाइड द मॉडल. आप यदि गूगल का एक ब्लॉग अच्छी तरह से पढ़ेंगे तो उसमें गूगल ने एक लाइन लिखा है कि इवन गूगल डजंट नो हाउ ऑल दिस थिंग्स हैपेंस इनसाइड द मॉडल एट द एंड ऑफ दिस कैलकुलेशन. मतलब स्टिल इट्स अ काइंड ऑफ अ मिस्ट्री बट वी एज ए ह्यूमन हैव डेवलप्ड दोस थिंग्स. मतलब कभी कभी तो ये भी मालूम नहीं चलता है कि आप कहाँ तक जा सकते हैं उसमें. कुछ ऐसे ब्लॉग है जिसमें लोगों ने पूरा का पूरा मॉडल का विजुअलाइजेशन किया है. मतलब जब आप लास्ट स्टेज पे पहुंचते हो तो वहां पे इतने सारे टेंसर्स दिखते हैं कि लाइक आप जूम करके करके थक जाओ फिर भी मालूम नहीं चलेगा कौन सा डेटा कहाँ था, ये कैसे कैलकुलेशन हो रहा है. बट इट इज ऑल अबाउट processing power, memory, the tensor, the mathematics, and all these wonderful innovators who have developed this technology. मतलब इतने सारे लोगों ने इकट्ठा काम किया है कि इवन नॉट अ सिंगल पर्सन इज एबल टू बी अ मास्टर ऑफ दैट थिंग कि हाँ ये मुझे सब मालूम है. जिसका डोमेन जो है उसको मालूम है. बट दीज आर अमेजिंग थिंग इन टर्म्स ऑफ. तो ये मैं फोटोग्राफ की जो बात कर रहा था उसमें हम क्या करते हैं, जैसे फॉर एग्जाम्पल मैंने मेरे पिछले 20 साल के फोटो लिए, उसमें अलग अलग कलर्स हैं, सभी के कलर फोटोग्राफ्स हैं. मैंने सिर्फ इतना ही बोला है कि यहाँ पे जो ये साड़ी का कलर है या शर्ट का कलर है तो ये रेड व्हाइट ब्लू ग्रे जो भी है दे दिया. फिर सब फोटोग्राफ को ग्रे स्केल में कन्वर्ट कर दिया या ब्लैक एंड व्हाइट में कन्वर्ट कर दिया. ब्लैक एंड व्हाइट में कन्वर्ट करने के बाद मैंने पुराने कोई फोटोज निकाले उसको भी उसमें से पास किया तो उसका मैंने रिवर्स वो किया इंजीनियरिंग, फाइनली इट शोज मी दैट्स नेक्स्ट और मे बी सिमिलर टू दैट पर्टिकुलर कलर। मतलब हमको इतना तो मालूम चलेगा कि ये शेड्स ऑफ ग्रीन था या शेड्स ऑफ ब्लू था या शेड्स ऑफ रेड था। मतलब वी कैन बी लिटिल बिट क्लोजर टू दोज थिंग्स। सो जो चीज पहले कभी नहीं हुई थी अभी भी हम उसको बाहर निकाल सकते हैं और निकाल के देख भी सकते हैं कि हाँ ऐसा होना चाहिए। अभी रिसेंटली किसी ने एक वो भी किया था कि लाइक मोनालिसा का जो पिक्चर है उस पे पूरा का पूरा एक्सप्रेशन डाल दिया था। मतलब आप कुछ भी बोलो तो मोनालिसा का क्या है, एक ही एंगल से फोटोग्राफ है, वी नेवर नो वो साइड फेस कैसा है या टॉप से कैसा है, मतलब साइड में से वो दोनों साइड से फेस कैसा दिखता है। somebody actually moved her head और उसको बात करते हुए दिखाया था कि how AI can even make these older like posters and like pictures live one kind of a thing. There are lots of papers on these sort of areas, generative adversarial networks और ये सब है, उसमें आप काफी अच्छा डीप में जा सकते हो और मतलब जहाँ पे भी आपको लगे कि मुझे यहाँ ट्राई करना है आप उस पर कर सकते हो काम।
Thank you.
मैंने एक स्टूडेंट को एक प्रॉब्लम दिया था कि मैं आपको एक पानी के 2 ग्लास देता हूँ, उसमें एक में मैंने नमक डाला हुआ है, एक में शक्कर डाला हुआ है, दोनों को पूरा का पूरा घोल दिया है, उसमें सिमिलर क्वांटिटी ऑफ सॉल्ट एंड शुगर हैज बीन एडेड। नाउ विदाउट टेस्टिंग कैन यू टेल मी वेदर इट इज सॉल्टी और स्वीट? मतलब एज ए ह्यूमन जस्ट बाय लुकिंग एट दैट वी कैन नेवर नो, बट यूजिंग एआई यू कैन डेफिनेटली डू दैट। Usually human intelligence says that like just by looking at the face we can identify whether the person is married or unmarried. Many a times it happens because for up to 16 or 18 we are sure that he is unmarried or she is unmarried, right? फिर 18 से 45 तक या 18 से 60 तक we are very much accurate in terms of identifying, right? तो ये कैसे मालूम चलेगा एआई मॉडल को कि ये, तो वी नीड टू प्रोवाइड द डेटा। फिर इवन इट इज इलॉजिकल टू टेल दैट लाइक लुकिंग एट द फेस ऑफ द पर्सन यू कैन फाइंड आउट द इनकम ऑफ अ पर्सन। मतलब ऐसा तो नहीं है कि किसी के फेस से हम मालूम मतलब कर सकते हैं, बट एज ए ह्यूमन वी आर इंटेलिजेंट इनफ एटलीस्ट टू प्रिडिक्ट समथिंग। हमको ये डे टू डे लाइफ में देखते ही है कि लाइक हाँ ये यहाँ तक तो कमाता होगा या ही मस्ट बी अ वेल एजुकेटेड पर्सन और मे बी समथिंग लाइक दैट। So provide as much as data and you can create a wonderful models based on that also. The things which seems illogical to predict based on some other parameters, because face is not the parameter by which you can identify number of things about the person, but still people use that, like even FBI and all of them uses the aura of a person also। मतलब इतना ज्यादा लोगों को ट्रेन किया है कि कोई यदि सामने आता है उसी से पहले मालूम चल जाता है कि whether the person is trustworthy or not। आप यूएस के डार्पा की वेबसाइट देखिए, जैसे वो डिफेंस एजेंसी का जो है डार्पा DARPA, हर साल एक प्रॉब्लम स्टेटमेंट रखती है, 6-7 प्रॉब्लम कि लाइक वी हैव दिस ओपन प्रॉब्लम्स फॉर ऑल द यूएस सिटीजन साइंटिस्ट प्रोफेसर। उसमें एक प्रॉब्लम ऐसा था कि क्रिएट एन एल्गोरिदम, क्रिएट अ डिवाइस, क्रिएट अ सॉफ्टवेयर, क्रिएट एनी ऑफ द थिंग्स विच यू नीड by which you can prove that this person is trustworthy or not. So you will get $75,000 as a prize first of all, and then you will be joining the DARPA's research team to make those things exactly. And now many of the things are still right now existing into the DARPA's research network by which people have made those things. मतलब आप यहाँ तक श्योर है कि आप 6-7 क्वेश्चन पूछेंगे, कुछ टेस्ट करेंगे तो ये मतलब जो भी पर्सन है whether he is a trustworthy or not, that. So people have developed that sort of logic, algorithm, devices, softwares and number of things all together. यदि आपके किसी स्टूडेंट ने सन का इंटरव्यू दिया है, CERN सन जो जिनीवा में है, if they apply for the internship, they will get a link for a video interview. Nobody would be there on the front end, it would be an AI interview directly. मतलब some questions will appear on the screen, student has to give simply the answers by switching on the video camera, or based on the answers and all the video analysis which will be done by AI tool running inside the AI Sun's software laboratory, they will reject or take it to the next step. मतलब ये भी लोगों ने किया हुआ है, it's already there. So for us, it is our job is to just transform all this knowledge to the students so that they can have a very best job or maybe they can perform well in the industry. Thank you so much.
Yes, sir.
Sir,
Very
excuse-
nice session.
Sir, excuse me.
Yes.
Okay.
Sir, Arduino is a RISC processor or CISC processor?
Can you repeat, sir?
Sir, Arduino is a CISC processor or RISC type processor?
क्या
Sir,
बोल रहे हैं,
your
sir?
question is not getting. Can you please type in the chat
Oh.
box?
Okay, ma'am. Okay, ma'am.
Yes.
is asking about RISC and CISC processor.
RISC and CISC
No,
processor.
no,
Whether it is RISC processor or CISC processor.
or CISC processor. That is my question.
Yes.
Kiran sir?
Reduced instruction set computer
think-
and
I think for Arduino, it's a normal ARM processor. I am not sure about RISC and CISC kind of a thing for this particular hardware. It is not actually meant for this sort of high-end computers. It is a normal microcontroller, and the powerfulness is that it is capable of running a smaller, lightweight models on that. Nothing more than that. So it is not exactly meant for those devices. It is just that like we are trying to bring AI to the embedded system. That is what the main concept is all about right now. That people are not interested right now to run AI and everything into computers. They want to make customized devices. And because of this making of the customized devices, the main approach and the run or the race is to move towards the edge computing. That is what the main important thing is all about.
Thank you, sir.
Any more question? So, sir, I think there are no questions now. So, thank you so
Ma'am,
much.
actually,
Yeah,
there is no question.
yeah,
Am I
yeah.
audible?
Yes.
Yeah. Yeah. Instead of asking question, actually, I want to just say thank you to sir that it has just been a day 3 and we have got to know so many new technologies that how the world is being changing nowadays. And today's session, it was really, sir, enlightening. Like the example that you gave of cold water and hot water, how that person has developed that algorithm and everything. It was really very new thing for us to learn. And thank you so much for today's session, sir.
मैं आपको एक आइडिया देता हूँ मतलब जो भी लेडीज स्टाफ मेंबर है like usually you have lots of choices in terms of clothes and perfumes and everything but can you make an AI suggester which can help you to where the next time whenever you are going for this sort of it's a kind of a recommendation system आपने यदि नेटफ्लिक्स में कोई एक मूवी देखी है तो इट विल रिकमेंड यू दैट लाइक दीज आर द मूवीज विच में लाइक यू में लाइक फॉर एग्जांपल अब आपने यदि कोई ऐसे आपके पूरे कपबोर्ड में पूरा कलेक्शन है जिसमें यू हैव सम सॉर्ट ऑफ काइंड ऑफ वैरायटी ऑफ क्लोथ्स एंड ऑर्नामेंट्स एंड परफ्यूम्स और जो भी है so it will suggest you next time whenever you are going for something so you can make a recommendation system like that only कि अभी एक जो प्रोजेक्ट किया था यूरोप में इट वाज क्रिएटिंग परफ्यूम यूजिंग एआई मतलब आपकी बहुत सारी चॉइसेस है लाइक यू हैव 20 चॉइस ऑफ डिफरेंट परफ्यूम्स नाउ एआई विल लेट यू नो एंड इट विल क्रिएट ए ऑटोमेटिकली लाइक मिक्सिंग ऑफ डिफरेंट fragrance and it will generate a perfume for you so this was something a new concept that perfumes created by a kind of a AI system similarly it can create various designs also मतलब चीज क्या होती है कि लाइक वी हैव फॉर अस लाइक मेल वी डू नॉट हैव मच चॉइस इन टर्म्स ऑफ क्लोथ्स आपके साड़ी में बहुत सारी चॉइस रहती है इंडिया में अलग अलग ज्योग्राफी में अलग अलग साड़ीज रहती है जैसे गुजरात में भी बहुत सारी चीजें हैं सो can you create something by which you can generate a new kind of a thing or a new kind of a fabric or a kind of a design or maybe I don't know what should I call it as a but AI can suggest you that this is one of the going to the best one and based on the recommendation based on the user feedbacks based on the usage of those things that can be also made possible मतलब हम हमारी रेस यही है कि हम खुद सोचना नहीं चाहते हम सब कुछ मशीन को दे देना चाहते हैं कि अब हमने सोचना भी बंद कर दिया नाउ वी डोंट वांट टू थिंक इवन वी आर नॉट इंटेलिजेंट इनफ वी हैव ऑलरेडी ट्रांसफर्ड एवरी इंटेलिजेंस टू द मशीन्स मतलब मैं ऐसा ही सोच रहा हूँ कि आफ्टर 70 years or maybe 100 years you will see a social network like Facebook that has been run and made by robots only and they are only talking over there मतलब एक फ्रीज किसी दूसरे फ्रीज को पूछेगा कि भाई मेरा टेम्परेचर बहुत ठंडा नहीं हो रहा है मैं क्या करूँ तो दूसरा एक रोबोट उसको सजेस्ट करेगा दैट वुड बी अ सोशल नेटवर्क ऑफ ऑल द रोबोट्स ओनली वी एज ए ह्यूमन विल बी जस्ट लुकिंग एट दोस थिंग्स एंड इवन लुकिंग एट दी बाउंड्रीज लाइक पॉलिटिकल बाउंड्रीज अभी कैसा है कि पॉलिटिकल पावर ज्यादा है या मसल पावर ज्यादा है या मनी पावर ज्यादा है दीज कंट्रीज आर रूलिंग पॉलिटिशियंस आर रूलिंग बट मे बी आफ्टर 100 years those people are having knowledge और जो भी मतलब wise और wisdom है जिसमें knowledge है जिसपे टेक्नोलॉजी का पावर है they will be ruling all these countries that is what my prediction is all about maybe अभी तो क्या है पॉलिटिक्स से सब चलता है मे बी आफ्टर फ्यू इयर्स टेक्नोलॉजी से सब चलता होगा आई एम नॉट श्योर वेदर इट इज राइट और रॉन्ग दिस जस्ट माय प्रेडिक्शन जो भी हम साईफाई मूवी में देखते हैं ऐसा ही है
Thank you so much, sir, for both the day's sessions.
Sir, one
And
more question,
yes.
please.
Yes, Mamta madam, please ask.
Sir, while training the Arduino, do we have to restrict at certain number of records, like you have mentioned 20,000 or likewise?
No problem, no problem. Because we are not training anything on the Arduino. We are directly loading the model on the Arduino. So training and all these things happens either in the Edge Impulse platform or maybe in the Google Colab, or maybe whether you are using a laptop, normal CPU will also do that training. Depends on the data, but usually like for our projects, our day-to-day projects for students or for our research purpose, we do not have that sort of much bigger data of say 100 GB or 200 GB, etc. Even though if you are doing that sort of research, normal GPU card and cluster will help us in running those things. Maybe it can take 1 week or 2 weeks or 1 month of time to train those. But definitely everything is done in terms of training on the computer itself. Once we get the output as a model, we directly load that model and we run the inference on the hardware itself. And whenever we convert it for Arduino, again, it becomes a kind of a zip shot of a version, converted model, I should say quantized model of a smaller size, and that we load on that hardware. So on Arduino, there is no problem when you run this model, but training is not going to be done on the Arduino itself. Everything will happen on the Edge Impulse platform or maybe Google Colab or your computer. Why I have shown this platform is because, you know, like there are hundreds of different libraries, hundreds of different tools and technologies. मैं यदि एक सिखाता हूँ तो कोई 99 लोग दूसरे पे काम कर रहे हैं. तो this is one of the online platform that everybody can reach there and everybody can start working on that. Because अभी क्या है कि like if you start learning about statistics, probability, linear algebra, Python and number of Keras and TensorFlow libraries and everything, it will take 2-3 years to go through all these things. But just to have a quick start and to understand, मतलब there are two options. Either आप read a book how to swim or else directly jump into the swimming pool. There are two different options you have. मतलब आप पहले पढ़ो 6 महीने की कैसे स्विमिंग करते हैं, हाँ पहले पैर हिलाते हैं फिर ऐसा करते हैं, लेकिन आप स्विमिंग कभी नहीं सीख पाओगे until and unless you jump into that. So I thought that let us have this sort of approach that show everything directly. मतलब उसमें से कुछ तो समझ में आ जाएगा और कुछ लोग start भी कर पाएंगे. That was one of the thing. And that is why I have not covered any mathematical part. Otherwise, it becomes very boring and nobody would have attended even. Simply just join into this. मुझे भी मजा आ गया आप लोगों के साथ. It was a very interactive one after many months because like there were all the faculties who were really interested in doing all this. Even I should say as compared to engineering faculties, आपको लोगों का मुझे background सबका मालूम नहीं है, लेकिन ज्यादा interactive one अभी यही रहा है मेरे लिए तो. Thank you so much.
Thank you so much, sir. Sir, can you please share your PPT because some of the participants were asking.
Yeah, I will share that.
Yes. Yes.
Should I
Thank you
upload
so
it?
much, sir.
Is
The
there any
session was really
is there any
awesome.
option
And
to upload?
it
Sir, I'll
started with the various points that we can work on.
हाँ बोलिए.
Mamta ma'am, please repeat.
I just wanted to thank Kiran sir for extending his knowledge and the various ideas that he has shared, because it helped us and now we can start and think on various real world problems as our day-to-day activities that we are conducting, like suggesting the perfume and likewise. So it's really we can think on. Thank you, sir.
बहुत सारी चीजें हैं, मतलब जहां पे मास इम्पैक्ट होता है ना कोई भी रिसर्च का, पीपल विल डेफिनेटली लव दोज थिंग्स. मैं यदि आपको ऐसा एग्जांपल देता हूँ कि आपने गूगल मैप देखा, उसमें बहुत सारी चीजें डिस्प्ले हो रही है. कभी आपने ऐसा देखा कि जिसमें पॉल्यूशन का लेवल दिखा रहा है कि यहाँ पे पॉल्यूशन ज्यादा है, आपको इस रूट से जाना चाहिए. सो यू कैन यूज ऑल दिस सेंसर्स एंड क्रिएट अ पॉल्यूशन मैप. एंड अगेन आप 6 महीने तक उसको रिकॉर्ड करो, एक मॉडल प्रिपेयर करो, ट्रेन करो, फिर वो प्रिडिक्ट भी करेगा कि आप यदि 4 बजे यहाँ से जा रहे हैं तो 6 बजे यहाँ पे पॉल्यूशन ज्यादा होगा, तो यू शुड टेक दिस रूट. So maybe this is going to be the future where you will get all the information on the map, but somebody has to start with.
Yes. और किसी को कुछ पूछना है? So I think all are very much happy, sir.
Thank you, man. It's my pleasure that all of you like that.
Yes, thank you so much, sir. From HRDC Nagpur also, I extend my thanks to you, sir, for accepting our invitation and conducting both the day sessions. Actually, we have planned with 2 sessions, and now that day also we were extending the session, and today also. Thank you so much, sir.
Extending the session and today also. Thank you so much, sir. Thank you. Bye bye to all of you.
Bye, sir. Good day, sir. Bye.
Thank you so much. Thank you, sir.
Bye.
Thank you, sir.
Bye, sir. Good day, sir. Bye.
Thank you.
Wonderful session, sir.
Thank you, sir. Thank you so much.
So, okay. Thank you, all of you. Just please look at the attendance. Just unmute yourself and give your attendance. Dr. Amitabh Haldar.
Yes, madam.
Yeah. Jageshwar Keche, sir.
Yes, madam.
Mugdha Gotkar.
Yes, ma'am.
Mamta Baheti. प्लीज अनम्यूट करिए और अटेंडेंस दीजिए। डॉक्टर ममता बाहेती, डॉक्टर राजेश पराते,
Present, madam.
डॉक्टर किशोर ढोले,
Yes, madam. Present.
डॉक्टर माया मावळे,
Yes, madam.
डॉक्टर सौरभ घोगरे,
Present, ma'am.
मिस्टर स्वप्निल शेळके,
Present, ma'am.
मिस अनिता दुबे,
Yes, ma'am.
मिस मयूरी गुर्दे,
Yes, ma'am.
डॉक्टर संतोष चौहान,
Yes, ma'am.
मिस रुपाली काळे,
Yes, ma'am.
मिसेस पूनम इंगळे,
Then, ma'am.
मिस्टर योगेश उशारे, योगेश उशारे सर। देखिए मीटिंग चालू करके कहीं तो भी भाग गए है ना, असं कराल तर कसं होईल? अब्सेंटी लगेगी अभी आज इनकी। डॉक्टर अर्चना साबळे, डॉक्टर अर्चना साबळे मॅडम, तुम्ही पण गेले का? अर्चना साबळे ऑल्सो अब्सेंट।
Madam Mamta.
हाँ मैडम, कहाँ गए थे जब मैंने नाम लिया था?
Madam पानी पीने।
क्या छोटे बच्चों के जैसे आंसर देते मैडम। ठीक है। डॉक्टर किशन देसाई सर, किशन देसाई सर, he was there, he was asking question and now he is not there. आपको मीटिंग लीव करने की इतनी घाई क्यों रहती है? सब लोग फटाफट लीव कर देते हैं रिसोर्स पर्सन चले जाने के बाद, फिर इंस्ट्रक्शन सुनते नहीं है और व्हाट्सएप ग्रुप में फिर मैसेजेस डालते हैं, है ना? मिस्टर लीलाधर गावेल।
Yes, madam.
या डॉक्टर वी जुडे निर्मल,
Madam.
जिनकी अटेंडेंस हो चुकी है प्लीज
Hello, madam.
डॉक्टर थिरुमूर्ति सर,
Present, ma'am.
या डॉक्टर गुना शेखरन सर,
Yes, madam.
डॉक्टर एस सेल्वम,
Present, madam.
डॉक्टर कुमारन,
Present, madam.
डॉक्टर श्रीनिवासन,
Present, ma'am.
ओके, मिसेस वसुमती,
Present, ma'am.
मिसेस उमा,
Present, ma'am.
दिनेश सिंह सर,
प्रेजेंट मैम।
या
मैम ये कल भी अटेंडेंस लिया था क्या ऐसे?
नहीं, ये आपको बता के अटेंडेंस नहीं ली जाएगी, इट इज अ सरप्राइज अटेंडेंस।
ओके, नहीं वो तो ठीक है, फिर कल मैं नहीं गया था
नो,
इसीलिए।
yesterday I have not taken.
ओके, थैंक यू।
मिस्टर प्रवीण शर्मा,
Yes, ma'am.
डॉक्टर श्याम सिहारे,
Yes, madam.
मिस्टर पूर्णा सेठी,
Present.
या मिस्टर मिसेस ज्ञान देवी, मैम, ज्ञान देवी मैम, काइंडली अनम्यूट इफ यू आर देयर, अदरवाइज अब्सेंटी लगेगी आपकी।
Hello.
Joseph, Mrs. Joseph. Yeah. Okay. So this is for our today's sessions.
मॅडम एक विचारायचं होतं
हाँ पूछिए
मॅडम
पूछिए पूछिए.
आपल्या साइट मध्ये आजच्या शेड्यूलला फक्त हे आहे रिपोर्टचा ब्लॉक आहे बाकी
तेच सांगते
क्वेश्चनर वगैरे काहीच नाही ना.
येस सर तेच सांगते मी आता. येस for today's sessions there is no quiz as such, but if you see the yesterday's part there Dr. Konde sir's quiz is there. If you gone through our Genomio site, कल के डेट में आपको कोंडे सर की क्विज आज ओपन दिखेगी. ठीक है. So you have to solve yesterday's quiz given by Miss GP Konde sir and today's report submission. आज के सेशन के ऊपर कोई भी क्विज नहीं है because MCQs are not provided by the resource person yet. So today there is only one quiz that was on yesterday's session given by Konde sir and report submission. और जिनका असाइनमेंट बाकी होगा, जिन्होंने कल असाइनमेंट सबमिट नहीं किया है, वो असाइनमेंट आज रात तक सबमिट करना है सबको.
मैडम रिपोर्ट का ऐसा कुछ स्पेसिफिक फॉर्मेट नहीं ना.
No, there is no as such specific format. You just have to mention the name of the resource person, name of the topic, and just start your writing abstract or brief account.
मैम हैंड रिटन
योगा क्लास का
मैडम
एक एक जन पूछिए प्लीज.
मैं मैडम टेबुलर फॉर्म में भेजता हूँ.
रिटन रिपोर्ट सबमिट कर सकते हैं मैडम.
यस हैंड रिटन रिपोर्ट का स्क्रीनशॉट या तो फोटो लीजिए और वो फाइल अटैच करके भी भेज सकते हैं.
ओके मैम थैंक यू.
मैडम योगा क्लास का भी करना है क्या?
नो सर ओनली योर कोर सब्जेक्ट. नो योगा सेशंस रिपोर्ट. ओनली दिस कंप्यूटर साइंस और आईटी वाले जो सेशंस हो रहे हैं उसी के.
मैडम यस्टरडे जो क्विज था वो अटेम्प्ट कर चुके हैं तो आज
नहीं
भी
सर
वही
कल नहीं कल आपने जो क्विज अटेम्प्ट किया दैट वाज ऑन कुलकर्णी सर्स लेक्चर. पहला वाला जो क्विज था मैं 1 मिनट आपसे शेयर कर देती हूँ सो दैट देयर शुड नॉट बी एनी कंफ्यूजन. आप अगर साइट में देखते हैं आज
ओके आई गॉट इट.
एक बार मैं साइट को दिखा देती हूँ. यस
मैडम वो यूजर स्कोर चेक किया, दोनों क्विज अटेम्प्ट किया है फिर भी वो यूजर स्कोर चेक करो तो वहां पर 0 ही बताता है मैडम.
कहाँ पे बोल रहे हैं सर?
ग्रेड
एक मिनट लेट मी शेयर दैट HRDC साइट. फ्रेंड्स कैन यू सी दिस HRDC साइट आपको दिख रही है?
यस मैडम.
हाँ ये देखिए एक सर ने अभी जो क्वेश्चन पूछा था. दिस इज अवर यस्टरडेज टास्क. Participants please mute yourself. Am I audible? See. सर ने अभी क्वेश्चन पूछा था. यस्टरडेज क्विज वाज ऑन दिस डॉक्टर नितिन कुलकर्णी सर्स लेक्चर दैट इज ऑन इमर्जिंग टेक्नोलॉजीज. उसी के नीचे आपको आज वाला जो क्विज है दैट वाज ऑन मिस्टर जीबी कोंडे सर्स लेक्चर यस्टरडे सेशन. ये वाला क्विज आपको आज सॉल्व करना है. आपको सिर्फ इतना ही ओपन दिखेगा. रेस्ट ऑफ द थिंग्स आर हिडन फ्रॉम स्टूडेंट्स मतलब पार्टिसिपेंट. तो आज आपको ये वाला क्विज सॉल्व करना है दैट इज ऑन द टॉपिक वेरियस वायरलेस या तो ओवरव्यू ऑफ वायरलेस सर्विसेज. फिर कल का जो असाइनमेंट था जिसकी डेडलाइन मैंने आज रात तक दी थी ये वाला पार्ट आपको कंप्लीट करना है. ये जो असाइनमेंट है दैट इज ऑन सीसी लाइसेंस, जिसके लिए आपको ये तीनों वीडियोस पहले व्यू करने हैं और उससे रिलेटेड असाइनमेंट सबमिट करना है जिन्होंने अभी तक नहीं किया होगा। यस्टरडेज रिपोर्ट यू हैव ऑलरेडी सबमिटेड, तो वो रिपोर्ट वाला ऑप्शन ओपन नहीं है। आज आपको सिर्फ ये वाला फिर रिपोर्ट आज के जो सेशंस हुए उसके ऊपर का ये रिपोर्ट सबमिट करना है। सो टुडे यू हैव टू डू 3 टास्क। One is quiz that was on yesterday's Konde sir's lecture. Second one is assignment on CC license, अगर कंप्लीट नहीं हुआ होगा तो वो करना है। और थर्ड है आज का रिपोर्ट सबमिशन। अभी आज के टास्क में किसी को कुछ डिफिकल्टी होगी तो पूछ लीजिए। सब क्लियर है?
नो मैडम।
यस
मैडम फर्स्ट क्विज में 13 क्वेश्चन था, वहाँ पे 10 दिखा रहा है।
वेयर?
जो मार्क सिक्योर जो होता है
सर दैट
वो
इज
10
ग्रेड।
दिखाता है।
सर दैट इज ग्रेड, वो मार्क्स के फॉर्म में नहीं देता है, वो ग्रेड के फॉर्म में देगा आपको। जब आप स्कोर कार्ड व्यू करेंगे ना आपका, तो फिर वो आउट ऑफ जितने भी रहेंगे 13 में से कितने मिले वैसा बताएगा। बट ओवरऑल वो जो ग्रेड्स में आप शीट में देखते हैं तो वो आपको आउट ऑफ 10 ग्रेड्स देते हैं। ये देखिए जैसे मैं अभी सभी का देख पाती हूँ, आपको दिख रहे हैं, ये आप लोगों के नाम है सारे, और आपने जो जो क्विजेस अटेम्प्ट किए हैं वो पूरा मेरे पास आ जाता है, आपका जो भी स्कोर रहेगा। एंड इट इज आउट ऑफ 10 वो स्कोर देता है आपको। जैसे अभी ये सत्ता मैडम ने अपना कोर्स लीव कर दिया है, वो छोड़ के चले गए, तो उन्होंने कोई भी क्विज अभी तक सॉल्व, मतलब वो भी है ही नहीं, आप पार्टिसिपेंट ही नहीं है। ममता बाहेती मैडम ने ये वाला क्विज अभी तक सॉल्व नहीं किया है। कल का क्विज सॉल्व नहीं किया है मैडम शायद आपने। देखिए अभी जो जो टास्क आपने परफॉर्म नहीं किया है वो अभी आप लोग, और किसने नहीं किया है यस्टरडेज क्विज?
मैडम असाइनमेंट सबमिट कर चुके हैं तो उसका स्टेटस दिखाता है कहाँ पे?
नहीं सर, वो मैं चेक कर रही हूँ मैन्युअली। जिसका नहीं आया होगा उस पर्टिकुलर टाइम में मैं इन्फॉर्म करूंगी अपने ग्रुप में।
क्योंकि वो सबमिट हुआ है कि नेटवर्क रिलेटेड इशू हो के सबमिट नहीं हुआ
नहीं
है।
सर, वो मेरे पास आ जाएगा। जो जिनका सबमिट नहीं हुआ होगा उनको मैं इन्फॉर्म करूंगी। अगर आपका नाम उसमें नहीं आता है तो समझ लीजिए कि वो सबमिट हो चुका है प्रॉपरली।
ओके ओके, थैंक यू।
ओके,
एक्सक्यूज मी मैम।
यस,
हां मी योगेश पुजारी बोलतोय मॅम।
हा सर, कुठे गेले होते अटेंडन्सच्या वेळेस? यू वर नॉट?
नाही ऍक्च्युअली मॅडम नाही मी इथेच होतो मॅडम, पण मला फक्त आवाज येत नव्हता आणि माझाही आवाज तुमच्याकडे येत नव्हता, अशी सिच्युएशन। तिन्ही सेशन मी अटेंड केले।
ठीक है, ठीक है, समझ में आ गया सबको? सो नाउ इफ यू हैव एनी क्वेरी यू कैन आस्क, अदरवाइज वी विल एंड हियर। Tomorrow we will meet in the morning at 7 o'clock for our yoga session, and rest of the part that is normal sessions रहेंगे। कल अपने 2 ही सेशंस रहेंगे ऑनलाइन, 11 बजे से 2:30 बजे तक, और सुबह योगा सेशन रहेगा। ठीक है, सो थैंक यू ऑल ऑफ यू।
ओके मैडम, थैंक यू वेरी मच।
ओके बाय मैडम।
बाय।
एक्सक्यूज मी मैम।
यस
मैम आज का जो गूगल फॉर्म का जो आपका लेक्चर थे, प्रोग्राम थे, वो फिर कब होंगे वो?
हाँ सर, मैंने आगे शिफ्ट किए हैं, वो हो जाए, मतलब वो टास्क आप लोगों को मिलेगा आगे पढ़ने के लिए आज का जो। ठीक है, वो कहीं तो भी एडजस्टमेंट कर दूंगी मैं बराबर। मतलब आपका मिस नहीं होगा कुछ।
ओके, थैंक यू मैम।
ओके, थैंक यू ऑल ऑफ यू।
ओके मैडम, बाय।
बाय।
थैंक यू।